There are places in the world that were never meant to disappear. Stone cities buried beneath sand, underground temples carved into silence, warriors frozen in granite, pyramids rising from forgotten plateaus. And yet today, most of them sit outside the pages of mainstream history, quietly waiting to be understood again. In this journey, we're not chasing fantasy or lost alien myths. We're walking through real archaeological sites, from submerged stone formations off Japan's coast to Bronze Age skull rituals in China, from underground resonance chambers in Malta to desert fortifications hidden beyond Saudi Arabia's famous tombs. So wherever you're watching from tonight, and whatever time it is there, settle in. The London Hammer. In the summer of 1936, near the small community of London in central Texas, a quiet discovery would begin a mystery that still circulates nearly a century later. The setting was simple: a creek bed scattered with limestone fragments, weathered by time and water. A couple exploring the area reportedly noticed a rock that seemed oddly shaped. When the stone later cracked open, something unexpected appeared inside. A hammer, not a fossil, not a mineral formation, an iron hammerhead, partially embedded in solid stone. At first glance, it looked like a normal tool, the kind a miner, blacksmith, or carpenter might have used in the 19th century. The iron was rusted, the wooden handle was aged. Nothing about its design appeared futuristic or unusual, and yet the surrounding rock raised questions. How did a modern-looking hammer become encased in stone? If the limestone formations in that region dated back hundreds of millions of years, as geological maps indicated, then how could a human-made object be trapped within it? That question transformed an ordinary tool into something far more intriguing. The object came to be known as the London Hammer, sometimes called the London Artifact, and over time it entered the world of so-called out-of-place artifacts, objects claimed to exist outside accepted historical timelines. But before we move into theories, we need to understand the land itself. The area around London, Texas sits on ancient sedimentary formations. Beneath the surface lie Ordovician limestone layers dating back nearly 450 million years, long before dinosaurs, long before mammals, long before humans. However, surface geology is not always identical to deep bedrock. Creeks erode older layers. Floods deposit new sediments. Minerals move through soil. The earth is not static. It is constantly reshaping itself. The stone surrounding the hammer was not a solid chunk of untouched bedrock pulled directly from our deep geological strata. Instead, studies indicate it was a concretion, a mineral formation that can develop when dissolved minerals in groundwater accumulate around an object. Concretions can form around shells, bones, leaves, even metal. When iron is exposed to moisture and oxygen, it oxidizes. As it rusts, chemical reactions occur. If mineral-rich water flows around it repeatedly, dissolved minerals can begin crystallizing and binding sediment particles together. Over time, sometimes decades, sometimes centuries, a hardened mass forms. It looks like natural rock. It feels like natural rock, but it may not share the same age as the ancient formations beneath it. The hammer itself resembles late 1800s American tools. Its shape and forging style are consistent with blacksmith-made implements common during that period. The wooden handle, partially mineralized, supports that time frame. Nothing about its construction requires prehistoric technology, yet the visual image is powerful. An iron tool fused inside stone, it challenges intuition. We tend to assume that if something is encased in rock, it must be as old as the rock. But geology does not always operate on simple assumptions. Surface environments can create rapid mineralization under the right conditions. Springs rich in calcium carbonate can form hard deposits in relatively short spans of time. Iron-rich soils can accelerate oxidation and binding. In certain cave systems, mineral build-up can encase modern objects within decades. The London hammer likely followed a similar process. Some have claimed laboratory tests showed unusual purity in the iron. Others suggested the absence of certain impurities common in modern steel. But metallurgical analyses indicate the hammer fits known historical forging practices. It is not stainless steel. It is not advanced alloy. It is ordinary wrought iron. Part of what keeps the London hammer alive in conversation is not scientific data but symbolism. It represents tension between curiosity and evidence. It invites the imagination to leap. Could there have been forgotten civilizations? Could history be incomplete? Could anomalies exist? These are natural questions. Curiosity is not a flaw. It is the foundation of discovery. But extraordinary claims require extraordinary evidence. And in this case, the evidence points toward geology rather than lost epochs. The hammer likely rested in a creek bed for years, perhaps dropped by a labourer, perhaps discarded after breaking. Mineral-rich water slowly built a concretion around the iron head. Sediment hardened. When the rock fractured years later, it created the illusion of deep antiquity. The illusion is compelling because it feels paradoxical, but nature produces paradoxes often. Consider petrified wood, once living trees transformed into stone over time, or bones fossilized within rock layers. Mineral replacement and sediment cementation are powerful forces. The earth preserves objects, sometimes in ways that surprise us. The London hammer does not rewrite human history. It does not place humans in the Ordovician period. It does not overturn geology. What it does do is remind us that context matters. An object separated from its full geological setting can appear mysterious. A photograph can amplify confusion. A story retold without nuance can grow more dramatic with time. Yet when we slow down, when we examine formation processes, metallurgical details, environmental chemistry, the mystery softens. And in that softening, something valuable remains. The London hammer teaches us about interpretation, about how easily appearances can mislead, about how important it is to understand natural processes before drawing historical conclusions. In a broader sense, it reflects a human tendency to search for the extraordinary within the ordinary. We want wonder. We want disruption of certainty, but sometimes wonder exists not in breaking scientific understanding, but in appreciating how complex and dynamic natural systems truly are. The quiet creek near London, Texas continues to flow. Limestone continues to erode. Iron continues to rust. Minerals continue to crystallize. And somewhere along that slow chemical dance, a simple hammer became something that looked ancient, encased, preserved, misunderstood for a moment. The London hammer remains a fascinating object, not because it proves a lost civilization, but because it reveals how geology and human artifacts intersect in unexpected ways. In the calm landscape of Texas, under open sky and shifting seasons, an ordinary tool once lay long enough for the earth to claim part of it, and in doing so, it created a story, not of ancient secrets buried in deep time, but of how carefully we must look before rewriting the past. The Antikythera mechanism, the ancient computer. Off the rugged Mediterranean coast of Greece, near the tiny island of Antikythera, a Roman-era ship once plied the waters more than 2,000 years ago. The vessel carried pottery, statues, glassware, and other luxury goods destined for wealthy patrons of the ancient world. But among its cargo lay something that would confound scholars for nearly a century. A corroded mass of bronze and wood fragments that once studied turned out not to be a simple tool or decorative object, but the most complex mechanical device known from antiquity. Today we call it the Antikythera mechanism, an ancient analogue computer reconstructed from gears, dials and inscriptions that reveal an extraordinary grasp of astronomy and engineering. Its story begins in 1901 when sponge divers exploring a long-lost shipwreck brought up a collection of artefacts encrusted with centuries of coral and limestone. The gears and wheels of the mechanism were discovered within this rubble, their configuration at first unrecognisable beneath the thick mineral accretions of the sea. For decades, the corroded fragments puzzled archaeologists. Only with advances in imaging technology, including X-ray and 3D scanning, did the true complexity of the mechanism begin to emerge. What appeared originally as a clump of bronze was revealed to be a system of interlocking gears, some with more than 70 teeth, precisely cut and aligned to model cycles in the heavens. Within the mechanism's structure are indications of lunar phases, solar years, eclipse prediction schemes, and even representations of the movements of the planets as understood in Hellenistic astronomy. The sophistication is staggering. Gear trains move in ratios consistent with astronomical cycles, long before clocks as we know them existed in medieval Europe. The Antikythera mechanism models the 19-year Saros cycle, which ancient astronomers used to predict eclipses. It includes indications of the Metonic cycle, a 235-month period after which lunar and solar calendars realign. There are inscriptions on the device's housing, fragments of Greek text that refer to celestial phenomena, calendar systems, and instructions for use. These writings suggest that the mechanism was not only functional, but also designed with educational or ritual use in mind. The mechanism challenges assumptions about ancient technology. Prior to its discovery, historians believed that complex geared machines did not exist until medieval clockmakers in Europe developed advanced gear systems centuries later. Yet here, in the 1st century BCE or CE, someone had already mastered the principles of differential gear movement and calendrical computation. The workmanship implies a tradition of mechanical knowledge, lost, obscured, and rediscovered much later. This raises questions about how knowledge was transmitted in antiquity. The mechanism may have been one of several similar devices. It may have been used at a philosophical school, an astronomical observatory, or a wealthy patron's study. Yet no other device of comparable complexity has survived from the ancient world, suggesting either that others were lost to time or that this represents a unique apex of technical ingenuity. Reconstructing the mechanism has required patience, imagination, and collaboration across disciplines. Scientists and historians have worked together, using advanced imaging to reverse engineer gear ratios and dial markings. Some reconstructions have produced working models that demonstrate how turning a hand crank on the device moves pointers across dials representing moon phases, zodiac positions, and eclipse cycles. Watching these models in motion, it is striking how seamlessly mechanical motion translates to celestial prediction, an analog calculator of the heavens. The surviving fragments of the mechanism do not reveal its complete original form, at least 30. Gears have been identified, but additional teeth and gear segments suggest that more mechanisms once existed within its housing. The face of the instrument likely bore multiple dials, concentric rings marking months, days, and astronomical cycles, all synchronized through the gear train. In understanding the Antikythera mechanism, we also understand something about the worldview of Hellenistic science. Astronomy in antiquity was not merely descriptive, it was predictive. Scholars observed the skies for decades and centuries, noting patterns and cycles. They developed geometrical models of planetary motion, ideas that would later ripple into medieval and Renaissance thought. The mechanism embodies that tradition, not only representing observed cycles, but encoding them into mechanical motion. The mechanism also reflects ancient craftsmanship, bronze casting, precision gear cutting, and careful inscription. These are not casual acts. They require workshops equipped for detailed metalworking, artisans trained in gear geometry, and patrons willing to support such endeavours. The result is not a crude instrument, it is a marvel of precision. Some scholars have also suggested that the mechanism may have had a didactic component, that is, it could have been used to teach students about celestial cycles, calendar systems, and the interplay between lunar months and solar years. The inscriptions, which include explanatory text and references to cycles used by ancient Greek astronomers, support this interpretation. The device may have served as both a functional calculator and an educational tool, translating abstract astronomical theory into tangible motion. Over time, the mechanism was lost with the wreck of its ship. The Mediterranean destroyed its wooden case and encrusted its surfaces with centuries of mineral accretions. For most of the 20th century, it remained fragmented, sitting in museum drawers as curiosity rather than clarity. But each technological advance in imaging deepened our understanding of its purpose and complexity. In the quiet halls of museums and laboratories, researchers continue to study the fragments, slowly uncovering each gear's ratio and each inscription's meaning. They imagine the hands that designed it, the eyes that watched celestial patterns for years, the minds that translated observation into gear trains and dials. The Antikythera mechanism is not evidence of extraterrestrial intervention or lost super civilizations. It is a testament to human ingenuity, a reminder that ancient people were capable of remarkable technical thought. Their tools may have been shaped with bronze and wood, but their ideas reached toward the heavens. And as we stand today, 2,000 years later, looking at gears turning in a reconstruction, we see not just a machine, but a bridge between human curiosity and the vast rhythm of the cosmos, where motion and measurement meet beneath Mediterranean skies, and where an old shipwreck gave the world one of history's most profound survivors of mind and mechanics, the Piri Reis map. In 1929, a fragment of an old map was rediscovered in the Topkapi Palace archives in Istanbul. Its surface was weathered, discoloured with age, the ink faded in places, yet the lines and names etched across its parchment spoke of distant lands, islands, coastlines, bays, and rivers drawn with careful attention, labelled with place names in graceful script. This artefact would later be identified as part of a world map compiled by the Ottoman admiral and cartographer Piri Reis in 1513. What makes this map remarkable, and the reason its story still draws interest today, is not merely that it shows parts of Europe, Africa, and the Americas in a time when global mapping was still in its infancy. It is that the map's coastlines appear to depict regions of the world that were unknown to Europeans at that time, including portions of the South Atlantic, and some have argued hints of a southern landmass beyond the known world. Scholars have scrutinised the Piri Reis map for decades, noting the accuracy with which it represents the western coasts of Europe and North Africa, the outline of Brazil's eastern shore, and even the Caribbean islands. For a map drawn in the early 16th century, just 2 decades after Christopher Columbus made his first voyage across the Atlantic, this was already impressive. Cartographers of the Renaissance were still refining their understanding of the globe, fusing new discoveries with older traditions of map making. Piri Reis himself was no ordinary sailor. Born in Gallipoli in the late 15th century, he served in the Ottoman Navy and became known for his expertise in navigation and charting sea routes. His maps drew on a wide range of source material, earlier Arab and Portuguese charts, accounts from Spanish explorers, and possibly even seafaring knowledge collected from captives or travellers. In his own notes written on the map fragment, Piri Reis acknowledged the use of diverse sources, some dating back centuries. What makes the map compelling to those outside mainstream cartographic history is the way certain coastlines appear, drawn with a precision that seems ahead of its time. In particular, some researchers have suggested that the southernmost portions of the map reflect an Antarctic coastline free of ice, a feature that, according to conventional scientific understanding, would not have been visible at any time in human history until modern surveys of the continent were conducted. This interpretation has driven speculative claims that the map reflects ancient knowledge of the southern polar region long before exploration vessels ever ventured near Antarctica. However, when examined carefully within the context of 16th century geographical knowledge, the map can be understood in more grounded terms. Renaissance cartographers often relied on a mix of empirical observation, second-hand reports, and educated inference. The shape of distant coastlines could be approximated from the descriptions of sailors, and large land masses beyond direct observation were sometimes filled in based on classical theories of geography. For example, the idea of a southern continent balancing the land masses of the northern hemisphere. Moreover, when the Piri Reis map is compared with other European maps of the same period, patterns emerge that reflect shared knowledge and mutual influence. Portuguese and Spanish explorers had already charted much of the coast of Brazil by the early 1510s. That information, circulating through Mediterranean ports and naval contacts, could easily have found its way into Piri Reis's sources. Portuguese cartographers in particular had produced detailed portolan charts showing the Atlantic islands and segments of the New World long before the Ottomans compiled this map. The so-called Antarctic feature on the map may instead represent an extrapolation of South America's southern reach, extended by guesswork or artistic convention. Renaissance map makers often embellished unknown regions with imagined coastlines and speculative geography, a practice common until global circumnavigation and systematic surveying provided more accurate charts. The map's mixture of confirmed coastline, approximate features, and imaginative extensions reflects the state of early modern cartography, a discipline in transition between medieval traditions and empirical modern science. It demonstrates how information moved across cultures, how explorers' reports were assimilated into navigational tools, and how map makers balanced observation with theory. Today, the Piri Reis map is not celebrated as evidence of ancient Antarctic knowledge, but as one of the earliest surviving maps to include parts of the Americas and the Atlantic world in a coherent, usable chart. It stands as a historical document that bridges eras between medieval manuscript map traditions and the global age of exploration that would soon redraw every known ocean. The narrative of the map also reveals something about the human drive to understand the world. In the early 16th century, explorers were pushing beyond known horizons, venturing into seas that had never been charted on European maps. Mariners collected coastal profiles, measured latitudes, recorded distances, and shared their observations upon return. Cartographers like Piri Reis sifted through these accounts, combining them with inherited knowledge in an effort to produce a comprehensive view of a world that was still astonishingly large and largely unknown. In that context, the Piri Reis map does not stand as an anomaly, but as a testament to a pivotal moment in human history, when the boundaries of the world were shifting, when sea routes connected continents, and when the limits of imagination and knowledge were being tested against the reality of a globe that was far more expansive than earlier generations could have conceived. As the sun sets on the Mediterranean horizon and shadows lengthen across the corridors of the Topkapi Palace Museum where the map is housed, one sees not a mystery of lost ancient Antarctica, but a milestone in the evolution of geographic knowledge, a chart made by hands steeped in tradition, curiosity, and the ceaseless human urge to chart what lies beyond the horizon. The Tully Monster. In the quiet coal country of northern Illinois, beneath layers of shale and ironstone, formed more than 300 million years ago, paleontologists uncovered a creature unlike anything living today. It did not resemble a fish, nor a worm, nor any familiar marine animal. Instead, it appeared as a slender body with a tail fin, a long projecting snout, and a pair of eyes mounted on a rigid horizontal bar, a design so unusual that even experienced fossil experts struggled to place it within the tree of life. This creature would become known as the Tully monster. Its scientific name, Tullimonstrum gregarium, honours Francis Tully, the amateur fossil collector who first brought it to scientific attention in the 1950s. Tully was exploring the fossil-rich deposits of Mason Creek when he split open a siderite nodule and found a strange silhouette preserved inside. At first, no one could identify it. It did not match any known fossil from the Carboniferous period. The Mason Creek fossil beds are extraordinary. During the late Carboniferous, this region was not dry land, but a humid coastal environment near the equator, filled with swamps, lagoons, and slow-moving rivers. Storm events would rapidly bury organisms in sediment, sealing them inside ironstone concretions that later hardened into nodules. These nodules preserved soft-bodied creatures in remarkable detail, including jellyfish, worms, and delicate arthropods that normally would decay beyond recognition. The Tully monster appears repeatedly within these deposits. It was not a rare anomaly. Hundreds, even thousands of specimens have been discovered, suggesting that this animal was a common member of its ecosystem. The anatomy, however, remains puzzling. The body is elongated and segmented, tapering toward a vertical tail fin that suggests active swimming. Near the front, a long, flexible proboscis extends forward, ending in a small claw-like structure lined with tooth-like projections. The eyes, set at either end of a transverse bar, would have given it a wide field of vision, perhaps useful in murky water where movement detection mattered more than sharp focus. For decades, scientists debated its classification. Some proposed it was related to mollusks, others suggested affinities with segmented worms. In 2016, a high-profile study argued that the Tully monster might be a primitive vertebrate, based on interpretations of internal structures that resembled a notochord and possible gill pouches. If true, it would represent a bizarre branch of early backboned animals. Yet subsequent studies challenged that conclusion. Reanalysis of the fossil structures suggested that what appeared to be vertebrate features could instead be artifacts of preservation, distortions created during burial and mineralization. The supposed gill structures, some argued, did not align with known vertebrate anatomy. The debate remains unresolved, though recent evidence leans toward the Tully monster being an invertebrate of uncertain affinity rather than a true vertebrate. What makes this fossil so scientifically important is not simply its unusual shape, but what it reveals about the evolutionary experimentation of the past. The Carboniferous period was a time of ecological diversity. Marine and estuarine environments supported a wide range of body plans, many of which have no modern equivalent. Evolution does not move in straight lines. It produces forms that flourish for millions of years and then disappear entirely. The Tully monster may represent one such lineage, a successful organism in its time, now extinct without leaving direct descendants. Reconstructed models suggest it may have been a mid-level predator, using its extendable proboscis to capture small prey. The tail fin indicates it could swim rather than crawl. The eye placement implies awareness of its surroundings in dim aquatic environments, and yet so much remains uncertain. There is no direct modern analogue to guide comparison. Every interpretation must rely on fossil impressions compressed into thin films of carbon within stone. When viewing a Tully monster fossil in a museum display, one is struck by how delicate it appears. A dark outline on a pale slab, as though painted by shadow. It is difficult to imagine this creature once alive, moving through warm, oxygen-rich waters beneath towering swamp forests filled with giant ferns and early amphibians. But for millions of years, it did exactly that. Then environmental conditions changed, ecosystems shifted, the lineage vanished. Only these impressions remain. The Tully monster is not mysterious because it contradicts science. It is mysterious because science is still refining its understanding of it. It stands as a reminder that the fossil record is incomplete and that ancient life included forms that challenge our expectations. In the stillness of the laboratory, under the glow of scanning equipment, researchers continue to study its anatomy, searching for clues hidden in mineral traces and subtle structures. And somewhere in the ironstone beds of Illinois, more nodules remain unopened, holding within them the outlines of creatures from a world that vanished long before the first dinosaurs walked the earth. The Tully monster endures not as a myth, but as a question, preserved in stone, patient, waiting for interpretation. The Coso artifact. In 1961, 3 men were searching the desert near the Coso Mountains in California. They were not archaeologists, they were rock collectors, looking for geodes, hollow stones lined with crystals that form over long stretches of time. The desert was dry and quiet. The landscape looked unchanged for centuries. Among the rocks they gathered was one that appeared ordinary on the outside. But when they cut it open, expecting to find crystalline formations inside, they instead uncovered something mechanical. Embedded within the hardened mass was a small object that resembled a spark plug. Metal, porcelain, a central rod. It did not look ancient, and yet it appeared encased in stone. The object quickly became known as the Coso artifact. Some early claims suggested that the surrounding rock was hundreds of thousands of years old. If that were true, then a manufactured component like a spark plug would present an extraordinary problem for established history. How could a 20th century technology exist inside ancient rock? The story spread quickly through alternative history circles. The artifact was cited as proof of lost advanced civilizations or of technological societies predating recorded history. The image itself, a spark plug seemingly fossilized, was powerful. But as with many anomalous discoveries, the key lies in understanding context. The Coso region contains volcanic formations and mineral-rich soils. In such environments, objects left on the ground can become rapidly encased in hardened mineral deposits. Concretions, similar to those formed around shells, bones, or even modern debris, can develop over relatively short geological timescales. When mineral-laden water flows through soil, dissolved materials such as silica or calcite can precipitate around a central object. Over decades, even less than a century, this process can create a hard, stone-like shell. Later analysis of the Coso artifact indicated that it closely matched a champion spark plug model produced in the 1920s. The internal structure, the ceramic insulator, and the metal configuration aligned with known commercial designs from that period. The surrounding material was not a pristine geode formed millions of years ago in untouched strata. It was a mineral concretion that had developed around a discarded object, likely left behind by machinery used in the region's mining or prospecting activities during the early 20th century. The desert preserves objects in unusual ways. Dry conditions slow decay, mineral-rich groundwater accelerates encrustation, volcanic ash layers complicate appearance. A mechanical component left in such an environment can quickly take on the appearance of something ancient. The Coso artifact does not require rewriting human history. It does not suggest advanced prehistoric industry. Instead, it illustrates how natural processes can create convincing illusions of deep antiquity. What makes this object fascinating is not that it defies science, but that it reveals how easily perception can mislead when geological processes are misunderstood. The artifact itself was reportedly lost from public record after changing hands among private collectors, adding another layer of intrigue. Without direct access to the object today, much of the discussion relies on photographs and earlier descriptions. But the broader lesson remains. When we encounter something that appears impossible, the first step is not to abandon established understanding, but to investigate the formation process carefully. Stone does not always equal ancient. Encased does not always equal prehistoric. The earth is dynamic. It reshapes, binds, and preserves modern objects in ways that can appear far older than they are. In the still desert air of California's Coso Mountains, a discarded spark plug lay long enough for minerals to surround it. When it was later cut open, the visual shock of metal inside stone sparked imagination. Yet sometimes the mystery lies not in lost civilizations, but in the quiet chemistry of soil and water working patiently over time. The Coso artifact stands as a reminder that extraordinary claims demand careful geological context, and that the boundary between natural formation and human artifact is not always immediately obvious. Beneath the desert sun, where wind moves across volcanic ridges and mineral crusts shimmer in the heat, even a simple spark plug can become a story. And sometimes the story is about how we interpret what we see. The megalithic stone balls of Bosnia. In the forests of central Bosnia, near the town of Zavidovici, there are shapes scattered among the trees that do not seem to belong there. They are heavy, rounded, almost perfectly spherical. Some are small enough to sit beneath a bush, others are massive, weighing several tons, emerging from the soil like fragments of some forgotten geometry. They are known simply as the Bosnian stone balls. At first glance, they look deliberate, too round to be random, too smooth to feel accidental, and because of that, they have inspired both archaeological curiosity and speculation. The largest of these spheres measures over 1 metre in diameter. Its surface is worn but retains a striking symmetry. Standing beside one, it is easy to feel that it must have been shaped intentionally, carved and smoothed by human hands thousands of years ago. But appearances, especially in geology, can be deceptive. The stone balls are composed primarily of iron-rich sedimentary rock. Geological studies indicate that they are natural concretions, formations created when mineral-rich water moves through sediment and gradually deposits material around a central nucleus. Over time, layer upon layer accumulates. The result can be remarkably spherical. Nature, under the right chemical and environmental conditions, tends towards symmetry. In sedimentary environments where iron oxides and other minerals precipitate evenly, round formations can develop as pressure distributes equally in all directions. This process can take thousands or millions of years, depending on conditions. The Bosnian spheres are not unique in the world. Similar stone balls have been documented in Costa Rica, New Zealand, and parts of Kazakhstan. In some cases, those examples are confirmed to be human-made. In others, they are clearly natural. The debate in Bosnia centres on which category these belong to. In the early 2000s, the stone balls gained international attention. Some researchers and independent investigators suggested they might represent ancient megalithic craftsmanship, perhaps linked to unknown prehistoric cultures. The visual impact certainly supports imagination. A nearly perfect sphere embedded in earth feels purposeful, but detailed geological analysis shows internal layering consistent with sedimentary concretion processes. The mineral composition matches surrounding bedrock formations. There are no tool marks, no consistent carving patterns, no evidence of transport or placement that would suggest organised human activity. Instead, the spheres appear where geology predicts they would appear, within iron-rich sedimentary zones subject to chemical precipitation. That does not make them less impressive. It simply shifts the story. Rather than evidence of a lost civilization, they become evidence of the Earth's capacity for unexpected geometry. In forests where moss grows thick and tree roots twist. Stone, these spheres sit quietly. Some are partially buried, others are cracked open, revealing layered interiors like cross-sections of planetary cores. The largest known Bosnian stone ball was uncovered in 2016, drawing renewed attention. Its near-perfect curvature reignited discussion, yet geologists maintain that natural concretion remains the most plausible explanation. What makes these formations so compelling is how closely they resemble intentional design. Humans associate symmetry with craftsmanship. When we see a sphere, we think of effort, but nature does not require intention to create form. Chemical gradients, pressure equalization, mineral deposition, these processes can produce shapes that rival human precision. Standing among the stone balls, the forest quiet around you, it becomes clear that mystery does not always mean artificial origin. Sometimes, mystery means we are encountering a natural process that feels unfamiliar. The Bosnian stone balls remind us that geology can surprise us, that the earth, over immense spans of time, sculpts shapes without hands, and that sometimes the boundary between artifact and formation lies not in appearance, but in careful study. As evening light filters through the trees of central Bosnia, casting soft shadows across round stone surfaces, the spheres remain where they formed, silent, heavy and patient, not monuments built by lost builders, but monuments to time itself. The stone fitting of Sacsayhuaman, high above the historic city of Cusco, where the Andes rise in layered ridges and the air thins into a cool mountain clarity, massive stone walls stretch across a hillside in a sweeping zigzag pattern. From a distance, they look like fortifications. Up close, they look impossible. This is Sacsayhuaman, one of the most extraordinary architectural achievements of the Inca civilization. The stones here are enormous, some weigh more than 100 tons. They are not uniform blocks stacked neatly in rows. Instead, they are irregular, multi-angled megaliths fitted together so precisely that even today, centuries after their construction, a knife blade cannot be inserted between them. No mortar holds them in place. No cement binds their edges. Each stone touches the next along carefully shaped interlocking surfaces. The question that echoes across this site is simple. How? Sacsayhuaman was constructed during the 15th century under the rule of the Inca Emperor Pachacuti and his successors. At that time, the Inca Empire was expanding rapidly, becoming the largest empire in pre-Columbian America. Cusco served as its capital, a sacred and administrative centre believed to have been designed in the shape of a puma, with Sacsayhuaman forming the head. The walls are built in 3 massive terraces, each forming a zigzag line that may symbolise lightning, a sacred force in Andean cosmology. The stones themselves were quarried from nearby limestone outcrops, some located several kilometres away. Transporting them required coordinated labour on a scale that still impresses modern engineers. The Inca did not use iron tools. They did not use wheeled vehicles for heavy transport. They did not rely on draft animals like oxen or horses. Instead, they relied on organisation, on manpower, on careful planning. Archaeological evidence suggests that thousands of workers, organised through a labour tax system known as mitar, contributed to state construction projects. Ramps, ropes, wooden rollers, and sheer human effort would have moved the stones slowly uphill. But transport is only part of the mystery. The shaping is even more remarkable. Each stone was carved to match the unique contours of the stones around it. This is not modular construction, it is sculptural architecture. The builders shaped one block, then adjusted the adjacent one until the two fit together perfectly. The precision is not decorative, it is structural. The Andes are seismically active. Earthquakes are common. And unlike rigid masonry bound with mortar, which can crack under stress, the interlocking stones of Sacsayhuaman are able to shift slightly during seismic movement, then settle back into place. In this sense, the walls are flexible. Resilient, designed not just for grandeur, but for survival. When the Spanish arrived in the 16th century, they were astonished by the scale and precision of Inca stonework. Much of Cusco's original architecture was dismantled and repurposed for colonial buildings, but Sacsayhuaman's largest stones were too massive to move. They remain. Some blocks rise over 4 meters tall. Their surfaces are smooth but not polished. Edges meet in irregular angles, some stones with as many as 12 sides, yet the joints align seamlessly. Modern theories about how the Inca achieved this precision remain grounded in practical methods rather than lost technologies. Experimental archaeology has demonstrated that stone can be shaped using harder hammerstones, abrasion techniques, and repeated fitting trials. It is slow work, labour-intensive, demanding, but possible. The achievement lies not in mystery machines, but in patience and mastery of material. There is also a cultural dimension. For the Inca, stone was sacred. Mountains were living entities. Apus, and construction was not merely engineering, but an act of alignment with the landscape. The walls of Sacsayhuaman follow the contours of the hill rather than imposing strict geometric symmetry upon it. The architecture feels organic, integrated, as if grown from the earth rather than placed upon it. Standing beside the largest stones, one feels their scale physically. The human body seems small in comparison, yet there is no sense of aggression in the construction. The zigzag terraces curve gently across the hillside. Wind moves through the grass. Clouds drift low across the Andean sky. The stones hold silence. Over centuries, earthquakes have shaken Cusco repeatedly. Spanish colonial structures collapsed and were rebuilt. But many of the original Inca foundations, including those at Sacsayhuaman, endured. Their secret lies not in impossible precision, but in intelligent design. Tight joints distribute weight evenly. Irregular shapes prevent linear fracture lines. Mass creates stability. Sacsayhuaman is often labelled a fortress, but its function may have been ceremonial as well as defensive. Archaeological evidence suggests it hosted state rituals and gatherings. Its commanding position above Cusco gave it symbolic authority as much as military advantage. From its terraces, the entire valley unfolds below. The city rests beneath. The Andes extend beyond. It is a place of oversight, of presence, of permanence. When visitors run their fingers along the stone seams, they often expect to feel unevenness. Instead, they feel continuity, a surface shaped by hand, yet aligned so precisely that light barely penetrates the gaps. The sight invites wonder, but it does not require supernatural explanation. The Inca were master stonemasons. They worked with the tools available to them. They refined techniques over generations. They organised labour at imperial scale, and they understood their environment deeply. The mystery of Sacsayhuaman is not that it defies physics. It is that it demonstrates what coordinated human effort, guided by cultural vision and practical intelligence, can achieve. As dusk settles over the Andes and shadows stretch across the zigzag walls, the stones darken slightly in the cooling air. They have stood for more than 500 years. They have endured conquest, weather, and tremors. They remain fitted together, not because they are magical, but because they were shaped with extraordinary care. And in that care lies the true achievement of Sacsayhuaman, a testament to precision, patience, and the enduring conversation between human hands and mountain stone. The Paluxy River tracks. In the limestone riverbeds of central Texas, where shallow water moves slowly over exposed rock, there are impressions pressed into stone that seem to belong to another world. Three-toed tracks, deep, rounded heel marks, long, stride-separated footprints. These are dinosaur tracks, preserved in layers of limestone dating back roughly 113 million years to the early Cretaceous period. The location is now part of Dinosaur Valley State Park, near the town of Glen Rose, where the Paluxy River cuts across ancient seabed sediments and reveals footprints left behind by large theropods and sauropods that once moved through muddy coastal flats. But in the early 20th century, something else was reported here. Alongside some of the dinosaur tracks, elongated impressions were interpreted by certain observers as human footprints. If true, that would suggest that humans and dinosaurs walked side by side. Such a claim would overturn established geology, paleontology, and evolutionary biology. The story of the Paluxy River tracks began in the 1900s, when local residents noticed unusual trackways exposed during periods of drought. As water levels dropped, more of the limestone bed became visible. Some impressions appeared long and narrow, with what looked like toe-like indentations at one end. Photographs circulated. Claims grew. By the mid-20th century, the site became a focal point for those arguing that mainstream science was incorrect about Earth's timeline. But careful study requires careful context. The limestone layers in which these tracks are found belong to the Glen Rose Formation, marine sediments laid down during a time when much of Texas was covered by a shallow inland sea. Dinosaurs occasionally crossed muddy tidal flats, leaving impressions that were rapidly buried and preserved. Dinosaur tracks are well documented in this region. Their anatomy is consistent with known theropod species. 3. Forward-pointing toes, claw marks, stride lengths, matching estimated leg proportions. The so-called human tracks are more complex. In some cases, erosion altered dinosaur prints, elongating them and smoothing out toe impressions. As sediment infilled and hardened, certain tracks lost their distinct three-toed shape, appearing more oval or elongated. Under certain lighting and erosion conditions, these altered tracks can resemble a human footprint. Other alleged human tracks were later shown to be carvings made during the 1930s and 1940s, when local residents, aware of public interest, created impressions in limestone to sell as curiosities. These carvings, once examined closely, show chisel marks and anatomical inaccuracies inconsistent with real fossilization. Over time, detailed geological and paleontological surveys were conducted. Trackways were mapped, stride patterns were measured, the supposed human tracks were analysed in relation to surrounding dinosaur prints. The conclusion reached by the majority of paleontologists is that there is no verified evidence of human footprints in Cretaceous limestone at Paluxy. The elongated impressions are either eroded dinosaur tracks or human-made carvings from much more recent times. This does not diminish the site's significance. On the contrary, the Paluxy River remains one of the most impressive dinosaur track localities in North America. Visitors can walk directly on exposed Cretaceous seabed and see the preserved steps of creatures that lived over 100 million years ago. Large sauropod trackways stretch in parallel lines, evidence of herd movement. Theropod prints appear with deep claw impressions, sometimes overlapping the sauropod tracks. It is a rare place where ancient motion becomes visible. The controversy surrounding the Paluxy tracks highlights an important aspect of scientific investigation. Extraordinary claims must be supported by extraordinary evidence. When geology, sedimentology, and anatomy are examined carefully, the timeline remains consistent. Humans evolved millions of years after the extinction of non-avian dinosaurs. But the persistence of the story reflects something deeper. When people stand beside dinosaur tracks and imagine that humans might have walked there too, the image is powerful. It compresses time. It collapses distance between past and present. Yet science moves slowly and methodically. It compares bone structure. It analyses sediment layers. It evaluates erosion patterns. The Glen Rose Formation is well dated. The fossil record of human evolution is well documented. These timelines align consistently across continents and disciplines. The Paluxy River tracks serve not as proof of coexistence, but as a reminder of how easily natural erosion can reshape fossil impressions, and how interpretation can drift when context is overlooked. Standing in the shallow water of the Paluxy River today, one can see dinosaur footprints stretching across limestone slabs. The river flows gently over them, sometimes hiding them beneath murky currents, sometimes revealing them again during dry seasons. The tracks are real, they are ancient, they are a direct connection to a Cretaceous shoreline where massive reptiles once moved across wet sediment. And in that quiet Texas riverbed, beneath open sky and drifting clouds, the true wonder is not that humans walk beside dinosaurs. It is that we can still see where dinosaurs once walked at all. The Montpellier Giant Skull, France, 1894. In the late 19th century, newspapers across Europe and America were filled with astonishing discoveries. Lost cities, buried treasures, strange skeletons unearthed during railway construction. It was an age of excavation and expansion. Railroads cut through countryside. Mines opened deep into hills. Foundations were dug for new buildings. And with every shovelful of earth, the possibility of discovery felt real. In 1894, a report began circulating about a remarkable find in France, near Montpellier. Workers, according to the article, had uncovered an enormous human skull. The description was dramatic. The cranium was said to be far larger than that of any known human. Measurements were provided. Speculation followed. If accurate, it would suggest the existence of giant humans in Europe's distant past. The story captured attention quickly, but to understand it, we must step into the world of 1894 journalism. The late 19th century was a competitive era for newspapers. Sensational headlines increased circulation. Archaeology was becoming popular, but scientific standards in reporting were not always rigorous. Stories of giants, ancient monsters, and mysterious relics frequently appeared in print. Many of these reports were based on rumour, misinterpretation, or deliberate exaggeration. The Montpellier giant skull story appears to belong to that category. No verified specimen of an oversized human skull from Montpellier in 1894 exists in any museum collection. No credible scientific publication from that period describes such a find in anatomical detail. No preserved remains have been catalogued or studied in modern times. Instead, what survives are references in newspapers, often secondary reports citing unnamed sources. In the 19th century, discoveries of large bones were sometimes misidentified. Fossils of prehistoric animals, mastodons, mammoths, and other large mammals were occasionally mistaken for human giants before scientific analysis corrected the record. It is possible that the original Montpellier report stemmed from such a misunderstanding. Large fossilized bones can appear strikingly human at first glance, especially when partial fragments are exposed. Without modern comparative anatomy or laboratory testing, misidentification was not uncommon. Another possibility is that the story was purely fabricated for public fascination. Newspapers of that era often reprinted sensational foreign stories without verification. A single exaggerated report could travel across continents within weeks, transformed slightly each time it was retold. The appeal of giants is ancient. From biblical Nephilim to European folklore, stories of oversized humans appear in many cultures. In the 19th century, these myths blended easily with emerging archaeological discoveries. As science began uncovering deep time, the public imagination sometimes filled gaps with dramatic possibilities. Yet when examined through modern scientific standards, there is no confirmed evidence of a race of giant humans in Europe's recent past. Human skeletal variation exists, of course. Individuals can grow unusually tall due to genetic conditions such as gigantism, but these cases are rare and the skeletal proportions remain within identifiable human limits. An enormous skull far exceeding known anatomical boundaries would be unmistakable and widely documented in scientific literature. The absence of such documentation is telling. The Montpellier giant skull remains part of a broader pattern seen throughout the 19th and early 20th centuries. Reports of giant skeletons that appeared in newspapers but left no trace in museums. Some attribute this to conspiracy or cover-up theories. However, historical research into these claims consistently reveals a simpler explanation: misreporting, exaggeration, hoaxes, or confusion with animal remains. What makes the story endure is not physical evidence, but narrative power. The idea that beneath European soil lies proof of forgotten giants appeals to something deep in human imagination. It suggests hidden chapters of history waiting to be uncovered. But science requires physical specimens, repeatable analysis, and peer review. Without those, a story remains just that, a story. In the quiet archives of old newspapers, the Montpellier report still exists as ink on yellowed paper. It reflects the excitement of its time, an era when archaeology was still forming its methods, and when headlines often raced ahead of verification. Today, Montpellier is known for its medieval architecture and academic institutions. No giant skull rests in its museums. No skeletal remains confirm the dramatic claims of 1894. The earth there holds Roman ruins, medieval foundations, and layers of human history, but not giants. The Montpellier giant skull serves as a reminder of how easily extraordinary claims can spread in periods of rapid discovery. It reminds us that curiosity must be paired with evidence, and that sometimes the mystery lies not in what was found, but in how the story was told. As dusk settles over southern France and old newspaper archives grow quiet in dimly lit rooms, the tale of the giant skull remains suspended in time, not as proof of lost beings, but as a reflection of an age when imagination often walked hand in hand with excavation. And in that balance between wonder and verification, the real story of the Montpellier giant skull quietly rests. The Dendera Light Relief. Along the west bank of the Nile, north of Luxor, stands one of the most beautifully preserved temple complexes in Egypt. Columns carved with the face of Hathor rise toward a ceiling once painted in deep blues and golds. The air inside is cool, even in the desert heat. Shadows collect in the deeper chambers. This is the Temple of Hathor at Dendera Temple Complex, and within its crypts, carved into stone walls below the main sanctuary, there is a relief that has sparked decades of speculation. It is often called the Dendera Light. The carving shows a long oval shape, somewhat resembling a glass bulb. Inside that oval is a serpent. The oval appears to emerge from a lotus-like base. Beneath it stands a figure holding what looks like a cable or support structure. To modern eyes, the image feels strangely familiar. Some claim it resembles an electric light bulb, and from that resemblance, a theory grew. The idea suggests that the ancient Egyptians possessed advanced electrical technology, that they used some form of lighting device inside temples and tombs, and that the Dendera relief is a depiction of this lost technology. It is a striking interpretation, but as with many ancient carvings, context changes everything. The relief is located in the crypts of the temple, narrow corridors used to store sacred objects. These crypts are filled with symbolic imagery. The carvings are not technical diagrams, they are religious scenes. The oval shape identified as a bulb is in Egyptian symbolism a representation of the womb of the sky goddess Nut, or sometimes a cosmic egg. The serpent inside is commonly interpreted as the god Harsontus, a form of Horus associated with rebirth and creation. The lotus flower at the base represents emergence, life rising from primordial waters. In Egyptian cosmology, creation is often described as a serpent emerging from a lotus in the waters of chaos at the beginning of time. When viewed within that mythological framework, the relief aligns clearly with known religious symbolism. The supporting figure beneath the oval is the god Djed, represented by a pillar symbolizing stability. The structure, sometimes interpreted as a cable, resembles a papyrus stem or stylized support element common in Egyptian art. Ancient Egyptian temple walls are filled with layered symbolic language. Scenes depict gods, rituals, offerings, cosmic cycles. Without understanding that symbolic vocabulary, it is easy to misread imagery through modern assumptions. Electricity as a practical technology did not exist in ancient Egypt. There is no archaeological evidence of wiring, glass bulbs, conductive metals arranged in electrical systems, or power sources capable of generating sustained light. Some have proposed that the so-called Baghdad battery, a separate artifact from Mesopotamia, demonstrates ancient electrical knowledge that might connect to Egypt. But even that object is widely understood to have been a simple galvanic cell possibly used for electroplating, not large-scale lighting. In Egypt, evidence of how tombs and temples were illuminated is well documented. Oil lamps and torches were used. Soot deposits on ceilings confirm this. Additionally, polished copper mirrors could reflect sunlight deeper into chambers. The Dendera light theory gained popularity in the 20th century, particularly within alternative archaeology circles. It reflects a broader fascination with the idea that ancient civilizations possessed hidden advanced technologies lost to time. But Egypt's achievements do not require hidden electricity to be impressive. Their engineering, mathematics, astronomy, and architectural precision are extraordinary within their historical context. The relief itself dates to the Ptolemaic period, around the 1st century BCE. By this time, Egyptian art had centuries of established iconography. The serpent in oval motif appears elsewhere in temple decoration and is consistently tied to creation mythology. When viewed under proper lighting in the temple crypt today, the relief's details become clearer. The carving is shallow but precise. Hieroglyphic inscriptions surround it, referencing deities and ritual language rather than technical instruction. The resemblance to a light bulb is coincidental, a product of modern familiarity. Humans naturally interpret unfamiliar shapes through familiar frameworks. A long oval with a central line resembles a bulb because we live in a world shaped by electric lighting. But in ancient Egypt, the imagery was cosmological, not technological. Standing in the cool dimness of the Dendera crypt, one can sense the weight of centuries of interpretation layered onto these walls. The stone is quiet, the carvings do not glow. They simply exist, symbolic, deliberate, religious. The Dendera light is not evidence of lost electricity, it is evidence of symbolic storytelling carved in limestone. It reflects how ancient Egyptians visualized creation, as life emerging from chaos, as energy taking form, as divine presence unfolding from darkness. And perhaps that is why the image feels powerful. It captures a moment of illumination, not electrical, but mythological. In the stillness of the temple, where filtered daylight barely reaches the crypt corridors, the relief remains exactly what it has always been, a carved expression of cosmology, a story in stone, and a reminder that mystery sometimes dissolves not through dismissal, but through understanding the language of the past. The Ulfbert crucible steel swords. In the cold rivers of northern Europe, pulled from peat bogs, burial mounds, and forgotten Viking graves, archaeologists have recovered swords that carry a name forged into their blades, a name written in iron, plus VL F BERH plus T. The letters are inlaid with precision, running along the fuller of the blade. To modern eyes, It looks almost like a brand, a medieval signature stamped into steel. These are the Ulfbert swords, weapons carried by elite warriors during the Viking Age, roughly between the 9th and 11th centuries. More than 170 examples have been discovered across Scandinavia, Germany, France, and even as far east as Russia. At first glance, they resemble other Viking swords of the period. Straight, double-edged blades, broad and balanced, designed for cutting and thrusting. But when metallurgists began analysing their composition in the 20th century, something unexpected emerged. Some Ulfbert blades were made from an unusually pure, high-carbon steel, far superior to most European metallurgy of the time. In an age when most swords were forged from bloomery iron, a material containing slag inclusions and variable carbon content, certain Ulfbert blades displayed steel with carbon levels approaching modern standards. Their structure was cleaner, stronger, more resilient. The question naturally followed: how did Viking-era smiths produce such advanced steel centuries before similar techniques became common in Europe? The answer lies not in lost technology, but in trade. During the early medieval period, much of Europe lacked the furnace technology necessary to produce consistently high-carbon crucible steel. However, in regions of Central Asia and the Middle East, crucible steel production had been practiced for centuries. This steel, sometimes referred to as Wootz steel, was made by melting iron in sealed crucibles with carbon-rich materials, producing a homogeneous high-carbon alloy. It was rare, valuable, and highly prized. Trade networks during the Viking Age stretched far beyond Scandinavia. Norse merchants and explorers travelled along river routes into Eastern Europe and down toward the Byzantine Empire and Islamic territories. Silver coins from the Abbasid Caliphate have been found in Viking hoards. Silk, spices, and other goods moved across these trade routes. It is entirely plausible that crucible steel ingots, or finished blades, travelled northward as well. Some Ulfbert swords, when tested, show chemical compositions consistent with imported crucible steel rather than locally produced bloomery iron. This suggests that certain smiths had access to materials far beyond their immediate region. The name Ulfbert itself remains a subject of debate. It may have referred to a specific master smith. It may have been a workshop name. It may even have functioned as a kind of medieval trademark, copied and imitated by others. In fact, not all Ulfbert swords are equal. Some are made of the superior crucible steel. Others are made from ordinary materials, yet still bear the inscription. This indicates that the name carried prestige. It was associated with quality, and so it was replicated, sometimes legitimately, sometimes as imitation. In that sense, the Ulfbert inscription may represent one of the earliest known examples of branding in weapon production. The blades themselves are elegant, long, straight, carefully balanced. The fuller running along the centre reduces weight while maintaining strength. The steel, when properly forged and heat treated, would have allowed the sword to flex without breaking, a critical advantage in combat. To a Viking warrior, a sword was not merely a tool. It was status, it was inheritance, it was identity. Swords were often named in Norse sagas. They were passed from father to son. They were buried with their owners. An Ulfbert sword would have been a rare and valuable possession. What makes these weapons fascinating is not that they defy history, but that they reveal how interconnected the medieval world truly was. We sometimes imagine the Viking Age as isolated northern raiders striking distant shores, but in reality, the period was defined by movement, exchange, and contact. Steel from Central Asia could travel thousands of kilometres. An inscription in Latin script could appear on a Scandinavian blade. Trade routes stitched continents together. The metallurgical quality of the best Ulfbert swords would not become common in Europe again until centuries later, when blast furnaces and improved steel-making techniques emerged in the late medieval period. But that does not mean the Vikings possessed lost industrial secrets. It means they participated in a global trade network. They acquired rare materials, they valued quality, and they forged it into weapons that would survive in riverbeds and graves for over 1,000 years. When archaeologists lift an Ulfbert blade from the earth, corrosion softened, but inscription still visible, they are holding not just a sword, but evidence of medieval globalization. In a museum display case today, under controlled lighting, the inscription gleams faintly against darkened steel. Plus V, LF, B, E, R, H, plus T. The letters are not mystical, they are deliberate. They represent craftsmanship, trade, and reputation. And in the quiet halls of those museums, far removed from the clash of shields and the roar of longships, the Ulfbert swords remain as silent witnesses to a time when steel, skill, and connection shaped the fate of warriors across Europe. The sarcophagi of Carragea. High in the cloud forests of northern Peru, where steep cliffs rise above deep green valleys and mist drifts slowly across the mountains, there are figures watching from the rock face. They stand upright, tall, silent. From below they resemble guardians carved from pale stone, positioned along a narrow ledge nearly 300 feet above the valley floor. These are the sarcophagi of Carragea. They were created by the Chachapoya, a pre-Inca culture who lived in the Andean highlands between roughly the 9th and 15th centuries. Often called the Warriors of the Clouds, the Chachapoya built their settlements in remote, elevated terrain, surrounded by forest and cliffs. Carragea is one of their most striking burial sites. The sarcophagi are not carved directly from stone. Instead, they are constructed from clay, sticks, and stone fragments, shaped into tall, anthropomorphic forms. Each one stands over 2 meters high. Their faces are stylized, large eyes, straight noses, solemn expressions. Some have skulls placed on top of their heads, perhaps as trophies or symbols of lineage. Inside each figure rests a mummy bundle. The Chachapoya practiced secondary burial rituals. The deceased were wrapped tightly in textiles, positioned in seated fetal postures, and placed within these vertical tombs. The sarcophagi were then sealed and positioned on the cliff ledge. Why there? The location was deliberate. The cliff face is nearly inaccessible without modern climbing equipment. By placing their dead high above the valley, the Chachapoya protected them from animals, looters, and environmental disturbance. But protection may not have been the only reason. Elevation carried spiritual meaning. In Andean cosmology, mountains were sacred. Height was associated with closeness to the sky, to ancestral spirits, to divine presence. From their perch, the sarcophagi overlooked the valley below, as if still watching the land of the living. The Chachapoya civilization flourished before the rise of the Inca Empire. When the Inca expanded into northern Peru in the late 15th century, they encountered resistance from the Chachapoya. Eventually, the region was incorporated into the empire, but the cultural identity of the Chachapoya remained distinct. The Carragea sarcophagi likely date to this late pre-Inca or early Inca period. Unlike the monumental stonework of Cusco or Machu Picchu, Chachapoya architecture often blends with natural landscapes. Cliff tombs, circular stone houses, mountaintop fortresses like Cuelap. Their burial practices reflect a strong connection between ancestors and territory. When Spanish chroniclers arrived in the 16th century, they described the Chachapoya as tall and fair compared to other Andean populations. Though such descriptions may reflect colonial perception rather than objective measurement, what remains undeniable is the uniqueness of their funerary art. Standing beneath the cliff at Carragea today, the sarcophagi appear almost surreal. Their pale surfaces contrast sharply against dark rock and vegetation. Weather has worn them over centuries, yet many remain intact. Some have collapsed, others still stand. The ledge itself is narrow, barely enough space for the line of figures. How they were placed there remains a testament to careful planning and courage. Workers likely used scaffolding or ropes to secure the tombs in position. Inside, the mummy bundles have provided valuable archaeological information. Textiles, offerings, and skeletal remains offer insight into Chachapoya life and health. Unlike Egyptian mummies, these were naturally preserved in dry, elevated air. The sarcophagi are not grand in the imperial sense. They are intimate, personal. Each one houses an individual, yet together they form a silent assembly. There is something profoundly human about them. They are not anonymous graves beneath soil. They are visible, elevated, remembered. Time has altered their surfaces, but their posture remains upright, as though still participating in the landscape. The Karagia sarcophagi are not evidence of lost giants or unknown species, though their size has occasionally inspired speculation. They are cultural expressions of ancestry, identity, and reverence. In the quiet of the cloud forest, with wind moving through Andean vegetation and distant birds echoing across the valley, the figures remain in place. They do not move, they do not speak, but they endure. And high above the Peruvian valley, carved from clay and intention, the Chachapoya ancestors continue to watch, silent witnesses to centuries passing below them. The Aramu Muru doorway. On the windswept plateau near Lake Titicaca, where the Andes stretch wide beneath a vast and restless sky, there is a carved doorway that does not lead anywhere. It stands alone in a sandstone cliff, a rectangular recess nearly 7 meters tall, carefully cut into solid rock. At its centre is a smaller niche, as though a second doorway once existed within the first. But beyond it, there is only stone. This is Aramu Muru. More precisely, it is known locally as Hayumarca, located near the Peruvian town of Juli, not far from the Bolivian border. The doorway faces open landscape, exposed to wind, sun, and centuries of silence. At first glance, it appears architectural, deliberate, too precise to be natural, and yet it opens into nothing. There is no chamber behind it, no corridor, no hidden tunnel, just the flat face of the rock itself. The mystery begins with its isolation. Unlike Machu Picchu or Sacsayhuaman, Aramu Muru is not part of a larger complex. There are no surrounding walls, no visible structures, no settlement remains directly attached to it. It is a single carved facade in a cliff. Local legend tells of a priest named Aramu Muru who fled Spanish conquerors in the 16th century, carrying a sacred golden disc from a temple. According to the story, he activated the doorway using the disc, and the rock opened, allowing him to pass into another realm. The legend describes the doorway as a portal, not a symbolic one, but literal. Over time, alternative interpretations have grown around it. Some claim it is a gateway to another dimension. Others suggest it aligns with cosmic energies or ancient advanced knowledge. But what does archaeology say? The region around Lake Titicaca has been inhabited for thousands of years. Long before the Inca, the Tiwanaku civilization flourished nearby, leaving behind monumental stonework and ceremonial architecture. Carved doorways are not uncommon in Andean cultures. The Inca and earlier civilizations frequently carved symbolic entrances into stone, representing transitions, sacred thresholds, or ritual spaces. Aramu Muru's design is consistent with this tradition. The large rectangular frame with an inset niche resembles other Andean carved portals. The smaller niche may have held offerings or ceremonial objects. The smoothness of the surface indicates intentional shaping, likely using stone hammering and abrasion techniques. Sandstone, the material of the cliff, is relatively soft compared to granite. It can be carved with sustained effort using harder stone tools. There is no evidence of mechanical cutting or advanced lost technology. The absence of a chamber behind the doorway suggests it was symbolic rather than functional. In Andean cosmology, thresholds carry meaning. The concept of passage between worlds, the living and the ancestral, the earthly and the spiritual, is deeply embedded in pre-Columbian belief systems. A doorway, carved into rock, could represent such a passage without requiring physical depth. Standing before Aramu Muru today, one feels its scale. The opening is tall enough to dwarf a human figure. The smaller central niche aligns roughly with chest height, as though marking a focal point for ritual contact. The surrounding landscape amplifies the atmosphere. The Altiplano plateau stretches vast and open. Lake Titicaca shimmers in the distance. Wind moves steadily across dry grasses. It is a place that feels ancient even without structures. Archaeologists date the carving tentatively to the late pre-Inca or Inca period, though exact dating is difficult due to the lack of organic material for radiocarbon testing. There are no inscriptions, no glyphs, no definitive records describing its purpose, but absence of written explanation does not imply supernatural function. It reflects cultural symbolism lost to time. In Andean tradition, mountains and rock formations are often considered living entities, apis, spiritual guardians of place. Carving into rock was not merely architectural, it was relational. The doorway may have marked a sacred site where rituals were conducted. Offerings could have been placed in the niche. Ceremonies may have involved passage symbolism without physical entry. The idea of a portal resonates because the structure looks like an entrance. Our minds expect depth, but sometimes architecture communicates meaning without utility. Aramu Muru does not lead to hidden chambers. It leads to interpretation. The story of the fleeing priest and the golden disc belongs to post-conquest folklore, a blending of indigenous memory and colonial disruption. Such legends often form around striking landscapes. When something feels powerful, narrative gathers around it. As the sun lowers over the Andean plateau and shadows lengthen across the carved facade, the doorway darkens. It remains still, solid, unopened, not because it hides another world behind it, but because it represents one. In the high silence near Lake Titicaca, where sky feels close and land feels endless, Aramu Muru stands as a threshold carved into stone, not a gate to another dimension, but a reminder of how ancient cultures expressed their understanding of passage, transformation, and the sacred nature of place. And sometimes that is mystery enough. The Egtved girl burial. In the rolling countryside of southern Denmark, near the small village of Egtved, a farmer once uncovered something beneath a burial mound that had rested quietly for more than 3,000 years. It was 1921. The mound had stood in the landscape since the Bronze Age, a low rise in the earth, blending into fields shaped by wind and weather. When it was excavated, archaeologists found a hollowed-out oak trunk placed carefully at its centre. Inside the trunk lay the remains of a young woman. She would come to be known as the Egtved girl. Her burial dates to around 1370 BCE, during the Nordic Bronze Age, a period of remarkable craftsmanship, long-distance trade, and complex social networks across northern Europe. What makes the Egtved girl extraordinary is not just her age, but her preservation. The burial mound had been built with layers of turf that sealed the oak coffin tightly. Over time, acidic conditions inside the mound dissolved her bones, but preserved her hair, clothing, and organic materials in remarkable detail. Her clothing is among the best preserved examples of Bronze Age attire in Europe. She wore a short corded skirt made of wool, designed with hanging strands that may have swayed as she walked or danced. Around her waist was a wide belt with a bronze disc at its centre, intricately decorated with spiral patterns. a symbol often associated with solar imagery in Bronze Age culture. She also wore a cropped woolen blouse and had carefully braided hair. Beside her lay a small box made of birch bark, possibly containing personal items. At her feet rested the cremated remains of a child, perhaps a relative, perhaps someone ritually connected to her. The oak coffin itself had been carved from a single tree trunk. The interior was shaped to cradle her body. A woolen blanket and a cowhide were placed carefully over her. The burial was not accidental. It was deliberate, careful, meaningful. For decades, archaeologists believed the Egtved girl was local, a young woman from the region buried according to the customs of her people. But modern science would reveal something unexpected. In the early 2000s, researchers conducted strontium isotope analysis on her hair, teeth, and nails. Strontium isotopes vary geographically based on local geology. By measuring these isotopes in human remains, scientists can estimate where a person grew up and where they travelled during their life. The results suggested that the Egtved girl was not originally from Denmark. Her isotopic signature pointed towards southern Germany, likely the Black Forest region. Even more intriguing, her hair showed changes in isotopic composition over time, indicating that she travelled repeatedly between regions during the last years of her life. This was not a stationary existence. This was movement across long distances. In the Bronze Age, such findings reshape our understanding of prehistoric Europe. Trade networks during this period were extensive. Amber from the Baltic reached Mediterranean lands. Bronze itself, an alloy of copper and tin, required materials sourced from different regions. Mobility was part of life. The Egtved girl may have been part of a high-status family involved in these exchange networks. Some researchers suggest she could have been married into a Danish community to strengthen alliances. Her clothing, particularly the belt plate, suggests elevated status. The solar motifs reflect cosmological beliefs tied to the movement of the sun, a central symbol in Nordic Bronze Age art. The short corded skirt has drawn attention as well. Unlike later medieval garments, it leaves the legs partially exposed. Interpretations vary, perhaps ceremonial, perhaps symbolic of youth or ritual role. We cannot know her name. We do not know her exact story, but we know she was approximately 16 to 18 years old when she died. We know she was carefully buried beneath a mound that marked her place in the landscape. And we know she travelled across what we now consider national borders, thousands of years before those borders existed. Standing in the National Museum of Denmark today, where her burial has been reconstructed, visitors can see the oak coffin, the clothing, the belt disc. It feels intimate, personal. The braids in her hair are still visible. The textile fibres still hold shape. She was once alive, walking, speaking, moving across forests and fields that look very different from the Denmark of today. Her burial mound was not isolated. Thousands of such mounds once dotted the Nordic landscape. Many have eroded or been levelled over time, but hers endured, and through it we glimpse a young woman from a world without writing, yet deeply connected through trade, belief, and travel. The Egtved girl challenges the idea that prehistoric life was static. She shows us that mobility, exchange, and cultural connection were already part of European society 3,000 years ago. In the soft northern light of Denmark, beneath skies that change quickly with passing clouds, her reconstructed coffin stands quiet in the museum, not as a relic of mystery, but as a reminder of how much human history moves, even when the past appears still. And beneath layers of turf and oak, a young traveller from the Bronze Age continues to tell her story, one strand of hair at a time. The Plateaus cave and the metallic library claims. Deep within the rainforest of southeastern Ecuador, where dense jungle presses against limestone cliffs and rivers cut through humid valleys, there is a cave system known as Cueva de los Tallos. The name comes from the oil birds, tallos, nocturnal birds that nest in the dark recesses of the cave. Their cries echo through the passages at night, giving the cavern an otherworldly atmosphere. But for decades, this cave has been associated with something far more dramatic than wildlife. It has been linked to the claim of a hidden metallic library, a vast underground archive of engraved metal plates said to contain the knowledge of an ancient advanced civilization. The story began in the 1960s when an Argentine-Hungarian explorer named Juan Morich reported that he had discovered artificial tunnels deep within Tallos Cave. According to his claims, these tunnels led to chambers containing metallic books, thin sheets of this metal inscribed with unknown writing, preserved in neat stacks like a subterranean archive. The idea spread quickly. The concept of a lost underground library, filled with ancient metal records, captured imaginations worldwide. Some linked the story to legends of pre-Columbian civilizations possessing hidden knowledge. Others suggested extraterrestrial connections. Speculation expanded rapidly. In 1976, a large-scale expedition was organised to investigate the cave system. It included Ecuadorian military personnel, scientists, engineers, and even astronaut Neil Armstrong as an honorary participant. The expedition was one of the most extensive cave explorations of its time. Teams descended into the caverns, mapped passages, documented geological formations, and conducted systematic surveys. What they found was a vast and complex natural cave system, but no metallic library, no carved stone corridors, no artificial chambers filled with metal plates. The cave itself is impressive enough without added legend. It descends steeply through vertical shafts and wide chambers, carved by water over thousands of years. Stalactites hang from ceilings. Underground rivers move silently in darkness. The limestone formations reflect the slow work of geological processes. The expedition's official reports concluded that the cave was entirely natural in origin. While it contained archaeological artifacts, including pottery fragments left by indigenous Shuar communities who entered the cave for ritual purposes, there was no evidence of advanced artificial construction. The metallic library claim remains unverified. No physical metal plates have been presented for scientific analysis. No confirmed artifacts matching the descriptions have entered museum collections. Yet the story persists. Why? Part of the answer lies in the power of narrative. The idea of a hidden archive beneath the earth, protected from time, containing ancient wisdom, resonates deeply across cultures. Similar legends appear in many traditions: lost cities beneath deserts, secret vaults beneath mountains, libraries hidden from conquest. In Ecuador, indigenous mythology includes stories of underground worlds and sacred caves. These oral traditions may have influenced later interpretations, but myth and geology are not the same. Cueva de los Tallos remains an important natural and cultural site. The Shuar people have long considered it sacred. Oil birds inhabit its chambers. The ecosystem within the cave supports specialized life adapted to darkness. Scientific exploration of the cave continues, focused on mapping, biodiversity, and geological study, not hidden metallic texts. The 1976 expedition stands as a reminder of how extraordinary claims are tested. When investigators enter with proper equipment, documentation methods, and peer-reviewed analysis, results tend to clarify rather than sensationalize. The absence of evidence is not evidence of concealment. It is evidence of careful examination. Standing at the mouth of Tallos Cave today, one sees dense forest stretching toward the horizon. The entrance drops sharply into shadow. Cool air flows upward from below. Bird calls echo faintly. It is easy to feel that something unknown lies beneath. But unknown does not automatically mean artificial. The earth itself carves immense spaces underground. Water shapes tunnels. Minerals form chambers. Darkness invites imagination. The Taos cave, metallic library remains a claim, a story without physical confirmation. The cave itself remains real, vast, natural, and sacred to local communities. And perhaps the most enduring lesson is this: mystery does not disappear when an extraordinary claim is examined. It simply shifts, from hidden civilizations to the quiet complexity of geology, from metallic books to the slow carving of stone. Deep beneath the Ecuadorian rainforest, Cueva de los Tallos continues to echo, with the wings of oil birds and the drip of mineral-rich water. Not a library of metal plates, but a cathedral of limestone and shadow, ancient in its own right and still waiting to be explored carefully, one chamber at a time. The Acapana Pyramid of Tiwanaku. On the high plains of western Bolivia, near the southern shores of Lake Titicaca, lies one of the most intriguing ceremonial centres of the ancient Andes. At nearly 4,000 metres above sea level, where the air is thin and the horizon stretches wide beneath immense skies, the ruins of Tiwanaku stand quiet against the wind. Among them rises a massive stepped platform mound known as the Acapana. More precisely, it forms part of the site of Tiwanaku, a pre-Inca civilization that flourished between roughly 500 and 1000 CE, long before the rise of the Inca Empire. At first glance, the Acapana appears to be a typical earthen pyramid, its stone facing long removed by erosion and later reuse. Today it looks like a large terraced hill with partially exposed masonry, but beneath its surface lies something extraordinary, a complex drainage system. The Acapana is not simply a mound of soil, it is an engineered platform constructed with carefully layered materials, stone retaining walls filled with compacted earth, gravel and clay. Embedded within this structure is a network of stone-lined channels designed to manage water flow. In the Andean highlands, rainfall can be intense and sudden. Without drainage, water can destabilize earthen construction. The builders of the Acapana understood this. They created internal conduits that directed rainwater downward through the pyramid, channeling it outward at controlled points. These drainage channels were not crude ditches. They were carefully carved stone ducts, fitted together with precision. Some sections show interlocking stonework similar to other Tiwanaku structures. Water flowed deliberately through the monument. This suggests the pyramid was not only architectural, but symbolic. Many archaeologists believe water played a central role in Tiwanaku ritual life. Lake Titicaca itself was sacred. Andean cosmology often emphasized the relationship between mountains, water, and their creation. The Acapana's summit likely held a ceremonial space, possibly a sunken courtyard or ritual enclosure. During rainfall, water would descend through the interior channels, emerging from sculpted outlets along the pyramid's sides. It may have appeared as though the structure itself was alive, breathing water. This was not accidental. The engineering required careful planning. Builders had to calculate slope gradients to prevent stagnation while avoiding erosion. Stone joints needed to be tight enough to prevent leakage into surrounding fill. The precision reflects a society deeply familiar with both landscape and construction. Tiwanaku itself was not a small settlement. At its height, it was a major urban centre controlling agricultural networks across the Altiplano. Raised field farming techniques allowed crops to grow in high altitude conditions, using water management systems that mitigated frost and drought. The Acapana fits within that broader pattern. Control of water meant control of stability, both practical and spiritual. Excavations in the 20th century revealed parts of the drainage system, though earlier looting and colonial stone removal had damaged much of the outer structure. Spanish colonists used some of the finely cut stones for church construction. Over centuries, erosion further altered the pyramid's appearance. But enough remains to demonstrate the sophistication of its design. The Akapana is often compared to pyramids in Mesoamerica or Egypt, but its purpose was likely different. It was not primarily a tomb, it was not simply a platform. It appears to have functioned as a ceremonial mountain, an artificial sacred elevation designed to connect earth, sky, and water. Standing at its base today, wind moving across the Altiplano, one can imagine how imposing it must have appeared when fully faced with dressed stone. Its terraces would have been sharply defined, water flowing through hidden channels during rain would have enhanced its ritual presence. In some interpretations, the pyramid represents a stylized mountain, reflecting Andean reverence for high peaks as sacred beings. Water descending through the structure may have symbolized fertility, renewal, and cosmic balance. Tiwanaku declined around the 11th century, possibly due to prolonged drought or political fragmentation. The once thriving urban centre gradually dispersed, but the Akapana remained, weathered, stripped, still holding its internal channels. Modern archaeological study emphasises that the drainage system is not evidence of lost advanced technology, but of intelligent adaptation to environment. Ancient engineers across the world solved practical problems using observation and accumulated knowledge. At Tiwanaku, they solved the problem of high altitude rainfall by designing a pyramid that could carry water through its core without collapsing. The result is both functional and symbolic. In the quiet of the Bolivian plateau beneath expansive Andean skies, the Akapana stands as a reminder that ancient civilizations were not merely builders of monuments, they were managers of landscapes, observers of water, architects of meaning, and through stone channels hidden within an earthen pyramid, the people of Tiwanaku left behind a system that still speaks, not of lost mysteries, but of masteries over one of nature's most powerful forces. The artificial eye of Shahr-e-Sukhteh, Iran. On the dusty plains of southeastern Iran, where the margins of the unforgiving Lut Desert meet the life-giving waters of the Helmand River, one of the earliest known urban centres in human history, once rose in complexity and culture. This was Shahr-e-Sukhteh, the burnt city, a sprawling Bronze Age settlement whose origins stretch back more than 5 millennia. At its height, this city covered vast areas of what is now Sistan and Baluchistan province, a testament to human ingenuity long before the age of written history. Among the many remarkable discoveries unearthed here, including early board games, richly decorated pottery, and evidence of long-distance trade, there lies one find that bridges archaeology and the story of human care and identity in a way few other objects can. In 2006, during systematic excavations of the cemetery at Shahr-e-Sukhteh, archaeologists uncovered the grave of a woman aged around 30. Embedded in her left eye socket was an astonishing object, a small, handcrafted artificial eyeball. This prosthetic eye, measuring only a few centimetres across, was not simply placed near the burial as an ornament. It was found in situ, exactly where her natural eye once sat. The object itself was meticulously crafted, made from light material, likely bitumen mixed with organic substances. Its surface was covered in a thin layer of gold. In the centre, a carved circle represented a pupil or cornea, while delicate lines radiated outward like rays of light. Tiny golden wires, less than 0.5 millimetre thick, were embedded within the structure, mimicking the pattern of blood vessels in a natural eye. 2 small holes on either side of the eye suggest that a thread or cord might once have held the prosthesis securely in place. The level of detail, the imitation of anatomy, the careful shaping to approximate the curve of a real eyeball indicates that this was not a symbolic ornament, but a crafted replacement intended to fit the wearer. This discovery pushes back the timeline of known ocular prosthetics by thousands of years and provides extraordinary insight into how ancient societies understood both loss and restoration. The fact that the recreational burial goods accompanying the woman were abundant, pottery, decorative objects, and textiles, suggests she may have held a special place in her community. What makes this find especially compelling is not just the age of the object, dating to roughly 2900 to 2800 BCE, but the suggestion that it was worn during her lifetime rather than simply placed in her grave after death. Microscopic wear patterns on the surrounding bone and socket indicate the prosthetic was in position for some time, likely helping to restore a sense of facial symmetry, identity, or social presence. In the words of researchers, this object should be considered the first known ocular prosthesis in medical history, a functional, wearable device created in a time when medicine and craftsmanship were rarely separable from each other. Beyond its technical details, the Shah-e-Sukhteh artificial eye speaks to something deeply human. It reveals the care and attention given to an individual who experienced physical loss. It suggests a concern for appearance, identity, and perhaps even dignity. These inhabitants of the Bronze Age world were not merely surviving, they were tending to each other in ways that resonate with our deepest sense of compassion and community. Standing before a reconstruction of the burial today, or imagining the woman who once lived nearly 5,000 years ago, we are reminded that archaeology is not only about structures and tools, it is about people. People who lived, moved, travelled, suffered, and were remembered. In the quiet desert plains of Iran, beneath the shadow of ancient walls and crumbled homes, the story of the artificial eye endures. It is a story of loss and restoration, of skill and empathy, and of the long arc of human ingenuity reaching back into the earliest chapters of urban civilization. The lion tombs of Dardan, Al-Ula. In the desert valley of Al-Ula, where towering sandstone cliffs rise from golden sands and ancient caravan routes once carried incense and spices across Arabia, there are lions carved into rock. They do not move, they do not roar, they watch. High along a cliff face in the archaeological zone of Dardan, a series of tomb entrances are marked by sculpted reliefs. Lions crouched in profile, their bodies elongated and stylized, positioned as guardians of the dead. This is Dardan, once the capital of the ancient Dardanite and later Lihyanite kingdoms, flourishing between the 9th and 2nd centuries BCE in what is now northwestern Saudi Arabia. The site lies within the broader cultural landscape of Al-Ula, a region rich in pre-Islamic history, rock inscriptions, and monumental tomb architecture. The lion tombs stand among the most distinctive elements of Dardan. Carved directly into the cliff face, the tombs are elevated several meters above ground. Level. Rectangular doorways cut into the sandstone lead into burial chambers within the rock. Beside some of these entrances, reliefs of lions are carved in low profile, their paws forward, heads alert, bodies stretched as though ready to rise. The lion, across ancient cultures of the Near East, symbolized power, protection, and authority. In Mesopotamia, it was associated with royalty. In Egypt, it embodied strength and guardianship. In Arabia, it appears here, silent, carved in sandstone, guarding the threshold between life and death. The Dardanite kingdom was strategically positioned along trade routes linking southern Arabia, the Levant, and the Mediterranean world. Caravans carrying frankincense and myrrh passed through this valley, bringing wealth and cultural exchange. Dardan became an urban centre, with temples, inscriptions, and elaborate burial practices. The lion tombs likely belonged to elite individuals, perhaps rulers, priests, or high-ranking members of society. Their elevated placement suggests status. Their sculpted guardians reinforce importance. Unlike the monumental rock-cut tombs of Petra, which would rise later under Nabatean influence, the Dadanite tombs are more restrained. Their facades are simple rectangles without elaborate columns or pediments. The lions are the defining feature. They are stylized rather than anatomically precise. Their bodies appear elongated. Their faces are simplified, yet the intention is clear. They are symbols, not portraits. Archaeological surveys indicate that not all tombs at Dardan bear lion carvings. This suggests a distinction, perhaps familial lineage, religious significance, or political status marked by the presence of the lion motif. Inside the tomb chambers, remains of human burials have been found, though centuries of looting and erosion have disturbed many interiors. The sandstone cliffs themselves have weathered over time. Wind and sand soften the carvings, edges blur. Yet the lions endure. Inscriptions found in the region, written in Dadanitic script, reveal glimpses of the society that built these tombs. Names of rulers, dedications to deities, and references to lineage appear carved into rock surfaces across Al-Ula. The Dadanites were not isolated. They participated in a network of trade and cultural exchange that connected Arabia to the broader ancient world. The choice of the lion as guardian may reflect influences from neighbouring civilizations, adapted into local artistic language. Standing below the cliff at sunset, when the sandstone glows amber and shadows lengthen across the carvings, the lion reliefs seem almost animated by shifting light. The valley is quiet now. No caravans pass, no incense smoke rises, but for centuries this place would have been alive with movement, merchants, pilgrims, political envoys. The tombs watched over it all. The elevated position of the burials also served practical purposes. In desert environments, placing tombs high on cliffs protects them from flooding and animal disturbance. It also marks them visibly within the landscape. The deceased were not hidden beneath earth. They were placed within the living rock, enduring. The lion tombs of Dardan reflect a society conscious of memory and status. They mark the transition from life into ancestry with symbols of strength. They do not claim supernatural gateways or hidden chambers. They claim continuity. Across the Al-Ula Valley, other archaeological sites, including the Nabatean tombs of Hegra, show the region's long tradition of rock-cut architecture, but the Dardan lion reliefs remain among the earliest examples. They represent a moment in Arabian history before Roman influence, before Islamic civilization, when local kingdoms shaped identity along desert trade corridors. Today, Al-Ula has become a focus of renewed archaeological research and heritage preservation. Excavations continue to uncover inscriptions and architectural remains that deepen understanding of the Dadanite kingdom. But even without excavation reports, the lions themselves communicate something timeless: guardianship, authority, presence. In the stillness of the desert, beneath a vast Arabian sky, the lion tombs of Dardan remain carved into sandstone cliffs, not as monuments to lost myth, but as quiet witnesses to an ancient kingdom that once thrived at the crossroads of trade, power, and belief. And as wind moves softly through the valley and light fades across the rock face, the lions continue to watch, patient, silent, enduring. The split rock of Al-Nasla. In the northwestern deserts of Saudi Arabia, not far from the ancient oasis of Tamar, a sandstone formation rises from the earth in a way that feels almost deliberate. Two towering halves of rock stand side by side. Between them runs a narrow, perfectly straight split. It is so clean, so precise, that at first glance it appears as though a blade has cut the stone in two. This is the Al-Nasla rock formation. Located near Tamar Oasis, Al-Nasla has become one of the most photographed geological features in the Arabian Peninsula. Visitors stand before it in quiet disbelief. The The separation between the two rock faces is remarkably even, running vertically from top to bottom. It does not appear jagged. It does not wander unpredictably. It forms a line, and that line invites questions. Was it carved? Was it split by ancient tools? Or is it the product of natural forces working slowly over thousands of years? The rock itself is sandstone, sedimentary rock formed from compacted sand grains deposited long ago when this region experienced different climatic conditions. Sandstone is strong, but it contains natural bedding planes and joints, weaknesses created during its formation. Over time, environmental forces exploit those weaknesses. Temperature in desert regions fluctuates dramatically between day and night. Sandstone expands under heat and contracts in cool air. Repeated cycles of expansion and contraction create stress fractures. Wind carries fine sand particles that abrade exposed surfaces. Occasional rainfall seeps into cracks, then evaporates, leaving minerals behind that widen fissures. Al-Naslar's split likely follows a natural joint line, a vertical fracture that formed within the rock mass long before it was exposed by erosion. Once the surrounding softer material eroded away, the joint became visible. The remarkable straightness of the split can be explained by the uniformity of stress distribution along that natural fracture plane. Geologists note that straight fractures are not uncommon in sedimentary rock formations. When pressure builds evenly along a weakness, the resulting crack can propagate in a relatively linear fashion. Over centuries, wind and weather refined the surfaces. The two halves now rest upon narrower stone pedestals, a result of differential erosion. The lower portions of the formation eroded faster than the upper mass, leaving each half balanced on a slender base. This balancing effect enhances the dramatic appearance. The formation looks sculptural, intentional, yet there is no evidence of human cutting tools, no chisel marks, no smoothing consistent with deliberate shaping. What makes Al-Naslar even more compelling is the presence of petroglyphs carved into its surface. Ancient carvings depict animals and human figures, likely dating back thousands of years, created by inhabitants of the region long before modern borders existed. These carvings confirm that the rock has stood exposed for a significant period, serving as a landmark for travellers and communities. The oasis of Tamar itself has a long history. It was once a key stop along caravan routes connecting Arabia to the Levant and Mesopotamia. Archaeological evidence shows habitation dating back to at least the Bronze Age. The rock split, therefore, would have been visible to generations of traders and desert dwellers. To them, it may have carried symbolic meaning. Natural formations often become cultural markers. Their unusual shapes inspire stories and myth, but geological explanation does not diminish wonder. If anything, it deepens it. Standing before Al-Naslar at sunrise or sunset, when the sandstone glows in soft light and shadows fall sharply along the split, one feels the scale of time involved. This is not a sudden break. It is the result of thousands of years of stress, erosion and exposure. The desert does not rush, it shapes, it sculpts, it reveals. The straightness of the split feels extraordinary because it aligns with our sense of symmetry, something we often associate with design. Yet nature produces symmetry often. Crystals form geometric shapes, basalt columns rise in hexagonal patterns, ice fractures along clean lines. Al-Naslar belongs to that quiet category of natural phenomena that resemble intention without requiring it. The two halves remain separated by a narrow gap, close enough that light barely passes through at certain angles, wide enough to step between. Visitors often place a hand against one surface, then the other, feeling the cool texture of stone that has endured desert winds for centuries. It is not a doorway, not a monument built by unknown hands. It is a fracture, refined by time. And perhaps that is the deeper story. In landscapes as vast as northern Arabia, we expect erosion to create chaos. Jagged cliffs, irregular surfaces, scattered rock. But sometimes erosion reveals order. Sometimes weakness becomes symmetry. The Al-Naslar split reminds us that geology works patiently. Pressure builds invisibly. Stress lines form beneath surfaces. And when they finally reveal themselves, the result can feel astonishingly precise. As evening settles over Timor and the desert sky darkens into deep blue, the two halves of Al-Naslar stand quietly balanced. No sound marks their separation. No movement widens the gap. They remain suspended in stillness, a natural sculpture shaped not by tools, but by time. And in that silence, beneath a vast Arabian sky, the split rock continues to invite the same question it has invited for generations. How can something so clean be so ancient? The answer lies not in mystery beyond nature, but in the patient power of it. The resonance chamber of the Hypogeum, Malta. Beneath the modern town of Paola in Malta, hidden below limestone houses and narrow Mediterranean streets, there exists a structure that does not rise toward the sky in monumental visibility, but instead descends quietly into the earth layer by layer, chamber by chamber, forming a vast subterranean complex that was carved more than 5,000 years ago by hands that had no metal tools, no written language, and yet possessed a refined architectural intelligence that continues to challenge our understanding of prehistoric design. This structure is known as the Hal Saflieni Hypogeum, and it stands as one of the most extraordinary underground ritual complexes ever discovered, not because of its scale alone, but because of the intentional shaping of space, sound, light, and symbolism within its limestone walls. The Hypogeum was accidentally discovered in 1902 when construction workers digging foundations broke through the roof of what they believed to be solid bedrock, only to reveal chambers beneath them, preserved in darkness for millennia, protected by the very earth that concealed them. As archaeologists began to explore the site, they realized they were not entering a cave formed by nature, but a deliberately carved underground temple complex consisting of 3 levels descending nearly 10 meters below ground, interconnected by narrow passages and carefully shaped rooms that mirror above-ground temple structures found elsewhere in Malta, such as Gantija and Hagar Kim. But among all the chambers within the Hypogeum, there is one particular room that has drawn sustained attention from researchers over the last century, a chamber often referred to as the Oracle Room, or more commonly in modern discussion, the Resonance Chamber. This chamber is not visually dramatic in the sense of massive pillars or towering ceilings, but its proportions are deliberate, its curvature intentional, and its small carved niche positioned with such precision that when a person stands within it and speaks in a low, steady tone, something extraordinary occurs. The sound does not simply echo, it resonates, it expands, it fills not just the room, but travels through adjoining spaces in a way that feels immersive, almost enveloping, as though the stone itself is participating in the act of speech. Acoustic studies conducted in recent decades have identified that the chamber resonates most strongly around 110 Hz, a frequency that corresponds closely with the lower range of a human male voice, and when sustained at that pitch, the vibration becomes physically perceptible, producing a sensation that can be felt in the chest cavity and skull as much as heard in the ears. Researchers using modern equipment have measured this phenomenon and confirmed that the geometry of the chamber enhances certain frequencies while dampening others, effectively creating a natural amplification effect that is not accidental in its consistency. Now the question arises, was this deliberate? Did the builders of the Hypogeum intentionally design this chamber to amplify sound, or is the acoustic phenomenon a fortunate byproduct of the carving process? To answer that, we must step back and consider the broader cultural context of Malta during the Neolithic period. The Maltese temple builders were among the earliest monument constructors in Europe, predating even the megalithic phases of Stonehenge and the pyramids of Egypt, and their architecture reflects a deep understanding of proportion, alignment, and symbolic space. Their temples above ground feature curved apses, central corridors, and carved altars, suggesting ritual use tied to cycles of life, fertility, and perhaps cosmological beliefs centered on earth and sky. The hypogeum mirrors these forms underground, suggesting that descent into the earth was not incidental but symbolic, possibly representing a return to a womb-like space, associated with rebirth or ancestral connection. Within such a ritual context, sound would not have been secondary. In pre-literate societies, voice carried power. Chanting, invocation, rhythmic repetition, these were tools of ceremony long before written scripture existed. Imagine standing inside the resonance chamber in near darkness, illuminated only by small oil lamps flickering against limestone walls painted with red ochre spirals, the air cool and still, the ceiling close enough to feel enclosed but not oppressive. A single voice begins to hum, low, steady. At first it seems ordinary, but as the note stabilizes, the chamber begins to respond. The sound thickens, it deepens, it spreads outward in all directions, not as an echo bouncing back, but as a sustained vibration saturating the space. Those standing nearby would feel the resonance in their bones. The stone would appear to hum in sympathy. In that moment, the chamber becomes an instrument, not mechanical, not technological in a modern sense, but architectural, an instrument carved from rock. Now it is important to remain grounded here. There is no evidence of advanced lost technology, no hidden machinery, no concealed devices. The resonance effect is fully explainable through acoustic physics. Curved surfaces concentrate sound waves, limestone reflects certain frequencies efficiently, and enclosed volumes can amplify standing waves at specific pitches. But what is remarkable is that prehistoric builders created a space where this effect is not random but consistent, whether by deliberate design or intuitive refinement through use. The resonance chamber produces an experience that feels ceremonial. Archaeological findings in the hypogeum indicate that it served not only as a ritual space, but also as a burial complex. The remains of thousands of individuals were once interred within its chambers, suggesting that it functioned as a collective ancestral site. Over centuries, the interplay between burial and resonance invites interpretation. Perhaps chants were performed to honour the dead. Perhaps sound was used to create altered states of awareness. Modern neuroscience has shown that sustained low-frequency sound can influence brainwave patterns, potentially inducing meditative or trance-like states. We cannot confirm that prehistoric Maltese societies understood this in scientific terms, but they may have recognised the experiential effect. Ancient architecture across the world often integrates sound, from Mayan temples to echo bird calls to Greek amphitheatres engineered for vocal projection. The hypogeum belongs to this lineage of acoustic awareness. And yet, unlike open-air theatres or temple courtyards, this chamber is enclosed entirely within the earth. Sound does not escape easily. It lingers. It envelops. It transforms space into presence. Today, access to the hypogeum is strictly limited to preserve its fragile microclimate. Humidity, temperature, and carbon dioxide levels are carefully controlled. Visitors move quietly through the chambers in small groups. Photography is prohibited. The resonance chamber remains dimly lit. When guides demonstrate the acoustic effect, they do so gently, allowing the space itself to respond. And when it does, the effect is subtle but undeniable. Not supernatural, not mystical, but powerful. 5,000 years ago, Without metal tools or written plans, a community carved into soft limestone and created a chamber that still reacts to the human voice. Above ground, Malta's sunlight glows warm against golden stone buildings. Below ground, in carved silence, the resonance chamber waits, and when a low tone enters the air, the chamber answers, not with mystery beyond explanation, but with resonance, the quiet collaboration between human voice and ancient stone. The Yonaguni Loop Road Formation. Off the southern coast of Japan's Ryukyu Islands, where the Pacific swells roll steadily toward coral reefs and strong underwater currents shape the seabed, divers descend into unusually clear water and encounter something that feels, at first glance, profoundly deliberate. Massive stone terraces rise from the ocean floor. Flat platforms intersect at sharp angles. Long, straight edges stretch across what appears to be an enormous stepped structure. Among these formations is a feature often referred to as the Loop Road, a curved, pathway-like band of stone that seems to trace a deliberate route along the submerged monument. This site lies near Yonaguni Island, discovered in 1986 by a local diver searching for hammerhead sharks. What he found instead was a massive underwater rock formation unlike anything previously documented in the region. The discovery quickly drew attention from marine geologists, archaeologists, and independent researchers. The structure sits roughly 25 metres below sea level, and its geometry, particularly its apparent right angles and stepped platforms, sparked immediate debate. Is it natural, or is it the remnant of a lost civilization submerged at the end of the last ice age? The Yonaguni Formation consists primarily of sandstone and mudstone belonging to the Yaeyama group, geological layers that formed approximately 20 million years ago. These sedimentary rocks are known for their bedding planes, natural layers that fracture along flat surfaces when exposed to stress and erosion. In underwater environments, wave action can exploit these planes. Over thousands of years, horizontal and vertical fractures can widen and separate, creating remarkably straight edges. This process is not rare in sedimentary geology. Cliffs and coastal shelves often fracture into rectangular blocks when tectonic uplift and erosion act together. The loop road itself appears as a gently curving, flattened section along the larger formation. Some divers describe it as resembling a constructed pathway, complete with consistent width and bordering edges. Others argue that its shape follows natural joint patterns and erosion lines shaped by underwater currents. Professor Masaki Kimura, a marine geologist from the University of the Ryukyu, has been one of the most prominent proponents of the idea that parts of the Yonaguni structure may show human modification. He suggests that certain terraces, stair-like features, and possible carved symbols indicate prehistoric construction or at least shaping. However, the majority of geologists maintain that the formation is entirely natural. The reasoning rests on observable geological processes. Sedimentary rock fractures in orthogonal patterns due to internal stress distribution. When tectonic uplift raises rock formations and later submerges them due to sea level changes, exposed layers can erode in a manner that creates strikingly architectural appearances. During the last glacial maximum, approximately 20,000 years ago, sea levels were significantly lower. The area around Yonaguni may have been above water at that time. As glaciers melted and sea levels rose, coastal formations became submerged. If the structure was above sea level during that period, it could have been subject to wind erosion and rainfall before submersion, enhancing its terraced appearance. The question of intentional carving remains unresolved in public imagination, though mainstream geological consensus leans strongly toward natural formation. The straight edges, flat planes, and stepped surfaces are consistent with large-scale jointing in sandstone. There are no confirmed artifacts, no tools pottery, inscriptions, or cultural materials recovered from the site that would indicate habitation or construction. Underwater archaeology relies heavily on contextual evidence. At Yonaguni, such context has not been found, yet the experience of descending toward the formation is undeniably dramatic. The monument rises from the seafloor like a submerged pyramid. Its terraces appear layered, as though carved with deliberate symmetry. Light filters through the surface above, casting shifting patterns across stone faces that seem too precise to be random. The loop road curves along one section, creating the impression of circulation, a pathway around a central core. But perception is powerful. Humans are pattern-recognizing creatures. We associate straight lines and right angles with design. When natural geology produces these forms at monumental scale, the mind searches for intention. Similar debates have occurred elsewhere in the world. At the Giant's Causeway in Northern Ireland, where hexagonal basalt columns appear engineered but are formed by cooling lava. At Bimini Road in the Bahamas, where rectangular stones resemble paved streets but are natural beach rock formations. Yonaguni belongs to this category of geological features that mimic architecture. Underwater currents in the region are strong, particularly the Kuroshio current. These forces continuously shape and smooth the rock surfaces. Marine growth adds texture and visual complexity. Some divers report seeing shapes resembling faces or carvings. Others point to linear grooves interpreted as tool marks. However, detailed geological analysis suggests these features align with natural fracture and erosion patterns. The debate persists largely because the formation is visually compelling. Standing on land, we expect mountains and cliffs to appear irregular. Underwater, when we encounter massive geometric shapes in silence, framed by blue light and drifting schools of fish, the effect feels amplified. If Yonaguni were confirmed to be man-made, it would imply a complex civilization existing in the region more than 10,000 years ago, long before known monumental architecture in East Asia. Such a conclusion would require overwhelming archaeological evidence. At present, that evidence does not exist, but the absence of proof does not diminish the wonder of the formation itself. Natural processes, acting over millions of years, can create structures that rival human architecture in scale and precision. The loop road, whether shaped by ancient hands or ancient waves, invites reflection on how we interpret landscapes. When we encounter order in stone, we instinctively attribute design. Yet geology operates with its own quiet logic: fracture, uplift, erosion, submersion. The Yonaguni Formation rests now beneath the Pacific, visited by divers rather than inhabitants. Fish weave through its terraces. Light dances across its edges. And the loop road continues its silent curve around a monument shaped by forces far older than any recorded history. In the end, the true story of Yonaguni may not be about lost civilizations or hidden cities beneath the sea. It may be about how easily nature can resemble intention, and how powerful that resemblance becomes when encountered in the depths of blue water. Beneath the waves of Yonaguni Island, the stone remains, silent, submerged, balanced between geology and imagination. Adam's calendar, Mpumalanga, in the rolling grasslands of Mpumalanga, South Africa, where low hills rise gently beneath wide African skies and wind moves quietly through tall dry grasses, there is a circle of standing stones that has become the centre of one of the continent's most debated archaeological claims. Locally, it is often referred to as Adam's Calendar. Officially, the site is known as Blaauwboschkraal Stone Ruins, part of a much larger network of stone-walled structures scattered across the region. At first glance, Adam's Calendar appears simple, a rough circle of upright stones arranged on a hilltop, overlooking valleys and distant ridges. There is no mortar, no towering megaliths. The stones are modest in size, weathered and partially embedded in the earth. And yet, from this simplicity has grown a narrative suggesting that the site is one of the oldest man-made structures on Earth, sometimes claimed to be over 75,000 years old, predating known civilizations by tens of thousands of years. Such a claim demands careful examination. The broader region of Mpumalanga contains thousands of stone ruins, including circular cattle enclosures, terraced agricultural sites, and settlement walls. Archaeologists attribute most of these structures to Bantu-speaking farming communities who lived in the area between approximately 1000 and 1700 CE. Radiocarbon dating, pottery fragments, and settlement patterns support this timeline. Adam's calendar itself sits within this landscape. The name Adam's calendar was popularized in the early 2000s by authors who proposed that the stone circle was an ancient astronomical observatory aligned to solstices and equinoxes, and that it may have been constructed by a lost advanced civilization. These interpretations often draw comparisons to Stonehenge, suggesting that the stones mark solar events with deliberate precision. When observed during certain times of year, shadows cast by specific stones do appear to align with sunrise or sunset points along the horizon. However, alignment alone does not determine age. Many stone circles and cattle enclosures can produce apparent alignments simply because circular arrangements intersect with the horizon at multiple points. The key question is context. Unlike megalithic sites in Europe, which are accompanied by datable organic material, burial goods, and layered occupation evidence, Adam's calendar has not produced credible archaeological evidence, placing it tens of thousands of years in the past. Mainstream archaeological consensus places the surrounding ruins within the Iron Age settlement period of southern Africa, likely linked to agricultural and pastoral communities. The stones themselves are locally sourced dolerite, a common igneous rock in the region. Their arrangement, though striking when viewed from certain angles, does not exhibit complex shaping or tool marks indicative of advanced stone carving. The site's elevated position on a hill may have served practical purposes: visibility, livestock management, territorial marking, or ritual gathering space. It is important to note that Iron Age African societies were highly organised, with established trade networks, metallurgy, and social structures. Recognising the likely Iron Age origin of the stone circle does not diminish its cultural value. Rather, it situates it within a documented historical framework. The extraordinary age claims, sometimes reaching back into pre-human antiquity, are not supported by peer-reviewed archaeological evidence. No datable artefacts from such remote periods have been recovered at the site. Claims of 75,000 year antiquity conflict with established timelines of human settlement patterns, architectural development, and tool usage. That said, the visual power of the site is undeniable. Standing within the stone circle at dawn, watching the sun rise over the Mpumalanga hills, the experience feels intentional. The stones frame the horizon. The air is still. The landscape stretches outward in quiet continuity. It is easy to understand why observers sense purpose. Ancient communities across the world used elevated spaces for gathering, ritual, and seasonal observation. The movement of the sun has always mattered to agricultural societies. Whether Adam's calendar was designed as an astronomical marker in a formal sense remains debated, but it is entirely plausible that the people who built the surrounding settlements understood seasonal cycles intimately. The broader Blauboschkraal complex reveals circular cattle kraals and homestead patterns consistent with Bantu architectural traditions. These stone walls once enclosed livestock, a central component of wealth and survival. Over centuries, weathering softened the walls. Vegetation grew through the gaps. The landscape reclaimed the structures, leaving only stone outlines visible from above. Modern aerial photography highlights the scale of the region's stone ruins. An extensive network stretching across valleys and ridges. Adam's calendar is one node within this larger system. Its isolation on a hilltop may reflect ceremonial or strategic function, but the narrative of extreme antiquity appears rooted more in speculative interpretation than in excavated data. When evaluating sites like Adam's calendar, it is essential to separate emotional resonance from empirical evidence. The circle is real, the stones are real, the landscape context is real, but extraordinary claims require measurable proof, datable organic remains, stratigraphic analysis, cultural artifacts tied to known prehistoric phases. At present, such evidence has not been presented. Still, the site invites contemplation. Across South Africa, the stone ruins of Mpumalanga speak to a long history of settlement, agriculture, and social organisation that predates European colonial contact by centuries. The recognition of these ruins as products of African Iron Age communities is itself a meaningful acknowledgement of indigenous architectural heritage. As the sun lowers over the Mpumalanga hills and long shadows stretch between the standing stones, the circle remains quiet. Wind passes through the grass, birds move overhead. The stones mark space, not necessarily 75,000 years of lost civilization, but centuries of lived human presence on the African plateau. Adam's calendar stands as a reminder that mystery often grows in the space between landscape and interpretation. Sometimes the deeper story is not one of hidden antiquity, but of cultural continuity, of communities who shape their environment in ways that endure quietly beneath open sky. And in that stillness, surrounded by stone and horizon, the circle remains, not a monument to forgotten super-civilizations, but a testament to the enduring human relationship with land, time, and the movement of the sun. Birs Nimrud and the memory of Babel. In the flat plains of southern Iraq, where the Euphrates once nourished some of the earliest cities in human history, a massive mound of broken brick rises from the earth, jagged against the horizon and scarred by time. This is Birs Nimrud. To archaeologists, it is the remains of the ancient ziggurat of Borsippa. To later tradition, it became something else entirely, a candidate for the legendary Tower of Babel. The site lies not far from Babylon, within the heartland of Mesopotamia, the land between rivers where urban civilization first emerged more than 5,000 years ago. The name Birs Nimrud is a later Arabic designation, linking the ruins to Nimrod, a powerful figure mentioned in biblical tradition. But the structure itself predates those stories by centuries. Historically, the ruins belong to the city of Borsippa, a significant religious centre dedicated primarily to the god Nabu, the Mesopotamian deity of wisdom, of writing and knowledge. At its centre stood a towering ziggurat, a stepped temple platform built of mud brick and faced with kiln-fired brick, rising in receding terraces toward the sky. Ziggurats were not pyramids in the Egyptian sense. They were not tombs, they were temple mountains, symbolic bridges between earth and the divine realm. Each ascending level represented movement toward the heavens, culminating in a shrine at the summit where rituals were performed. The ziggurat at Borsippa was constructed in stages, with major building phases during the Neo-Babylonian period, particularly under King Nebuchadnezzar II in the 6th century BCE. Nebuchadnezzar left inscriptions describing restoration work at the site, acknowledging that earlier versions of the structure had fallen into ruin before his reconstruction efforts. He described the ziggurat as reaching toward the sky, a phrase that resonates with later biblical imagery. In the book of Genesis, the Tower of Babel is described as a structure built in the land of Shinar, intended to reach heaven. According to the narrative, human ambition led to divine intervention, the confusion of languages, and the scattering of peoples. Over time, Travellers and scholars visiting Mesopotamia encountered vast, crumbling ziggurats rising from the plains and naturally connected these ruins to the Babel story. Beers Nimrud, with its towering remnants and partially collapsed upper structure, seemed to match the imagery. Even today, the uppermost section of the ruin appears twisted and fragmented, as though shattered by immense force. 19th century explorers described it as looking struck by lightning, reinforcing the mythic connection to divine punishment. But archaeology tells a more grounded story. The structure's damage is consistent with natural decay of mud brick over millennia, compounded by earthquakes, erosion, and the removal of bricks for reuse in later construction. The core of the ziggurat was built from sun-dried mud brick, strong when maintained, but vulnerable once protective outer layers deteriorate. When the facing bricks fell away, the inner mass began to erode rapidly. What remains today is a dramatic ruin, but not a divine ruin. The original ziggurat likely stood over 50 metres tall, its terraces painted in vibrant colours, perhaps white, black or red, depending on level. A staircase or ramp system would have allowed ceremonial ascent. The summit shrine would have housed sacred objects and served as the focal point for offerings and ritual acts. Borsippa itself was an important urban centre, closely linked to Babylon politically and religiously. Nabu, the city's chief deity, was associated with writing and scholarship. His temple complex drew pilgrims and officials alike. In this context, the ziggurat was not an act of defiance, but an expression of devotion. The connection to the Tower of Babel arises not from direct evidence, but from narrative overlay. The biblical account may have been inspired by collective memory of Mesopotamian ziggurats, monumental structures dominating flat landscapes, appearing to reach skyward. When later Jewish exiles encountered Babylon during the 6th century BCE, the sight of these towers could have shaped storytelling traditions. But Beers Nimrud itself is clearly identified through inscriptions as the ziggurat of Borsippa, not Babylon proper. The true ziggurat of Babylon, Etemenanki, once stood closer to the city centre of Babylon itself, and it too has been proposed as the inspiration for Babel. Both structures share architectural form, both dominated the skyline, both represent the ancient Mesopotamian impulse to build upward toward the divine. Standing at Beers Nimrud today, the wind moving across open plains, the structure feels immense even in ruin. Bricks stamped with Nebuchadnezzar's name lie, scattered across the ground. The sun casts long shadows across broken terraces. The sense of antiquity is undeniable, but the ruin is not evidence of a universal language shattered in a single moment. It is evidence of human ambition expressed through architecture, a civilization constructing sacred space through mud brick and geometry. The memory of Babel persists because it speaks to human themes: unity, pride, fragmentation, language. The ziggurat of Borsippa persists because it was physically real, engineered, restored, used, and eventually abandoned. The two narratives intersect not in literal identity, but in shared symbolism. In the fading light of evening, when the silhouette of Beers Nimrud stands dark against an Iraqi sunset, it is easy to see how ancient travellers might have imagined it as the remnant of a cosmic event. But beneath the legend lies archaeology, and beneath archaeology lies intention, the intention of a society to create a sacred axis between ground and sky. The Tower of Babel may belong to scripture. Beers Nimrud belongs to history, and in the space between story and stone, the memory of ancient Mesopotamia continues to rise. Not in defiance, but in quiet endurance across the plains where civilization first learned to build. Shimao, the forgotten stone city of northern China. On the windswept Loess plateau of northern China, in a landscape of deep ravines and wide ochre plains, Carved by centuries of erosion, archaeologists uncovered something that did not fit comfortably within the traditional timeline of early Chinese civilization. High above the Tuwei River Valley in Shanxi province lies the vast stone settlement of Shimao, a 4,000-year-old fortified city whose scale and complexity challenge long-held assumptions about where and how early Chinese states emerged. For much of the 20th century, Chinese archaeology centered its narrative of early civilization along the Yellow River's central plains, particularly around sites associated with the early Tu culture, often linked to the semi-legendary Xia dynasty. Shimao did not appear in those early histories. It was not mentioned in classical texts, and for decades it was misidentified as part of the Great Wall, its stone ruins attributed to, much later, defensive construction. Only in the early 21st century did systematic excavation reveal the true age of the site. Radiocarbon dating places Shimao around 2300 to 1800 BCE, contemporaneous with, or slightly earlier than, the earliest dynastic states traditionally recognized in Chinese history. What emerged from excavation was astonishing. The city covered nearly 400 hectares at its peak, enclosed by massive stone walls built from carefully fitted blocks. At its centre rose a monumental stepped platform, often described as a pyramid, with a base spanning approximately 70 metres in height from its lowest visible foundations. This was not a modest settlement, it was a capital. The pyramid-like platform appears to have supported elite structures at its summit, possibly palatial or ritual buildings overlooking the entire city. The terraces were reinforced with stone retaining walls, decorated in places with jade inlays embedded within masonry. The use of jade is significant. In ancient China, jade symbolized power, spirituality, and legitimacy. Its presence within defensive walls suggests ritual meaning integrated directly into architecture. But among the most unsettling discoveries at Shimao were human skulls embedded within the city's outer walls. Excavations uncovered evidence of mass human sacrifice, primarily young women, whose skulls were placed within the stone ramparts during construction phases. Archaeologists interpret these as foundation sacrifices, rituals intended to consecrate or protect monumental architecture. Such practices were not unique to Shimao. Human sacrifice has been documented in various early civilizations, including Shang Dynasty China, Mesopotamia, and Mesoamerica. But at Shimao, the scale is notable. The skull deposits indicate organized ritual violence, perhaps marking the establishment of political authority through controlled terror or cosmological belief. The presence of defensive walls suggests that Shimao was not isolated. It existed within a network of competing regional powers across northern China during the late Neolithic period. Its architecture combines influences from steppe cultures to the north and Yellow River traditions to the south, suggesting a crossroads of cultural exchange. This complicates the older model that positioned the Central Plains as the sole cradle of Chinese civilization. Shimao demonstrates that complex urban societies were emerging simultaneously in multiple regions. So why was it absent from early historical narratives? The answer lies not in deliberate erasure, but in archaeological visibility and textual bias. Early Chinese historiography relied heavily on written records preserved from later dynasties. If a civilization did not leave written documentation that survived into classical periods, it risked fading from memory. Shimao predates known writing systems in China. Its society may not have developed script, or if it did, no examples have yet been found. Without textual continuity, its memory did not enter canonical histories compiled centuries later. Additionally, geographic focus shaped archaeological interpretation. For decades, research concentrated in central regions tied to historical capitals. Peripheral areas like northern Shanxi received less attention. When Shimao's stone ruins were first surveyed, their scale was underestimated and their age misclassified. So it was only with modern excavation techniques, stratigraphic analysis, and radiocarbon dating that the city's true antiquity became clear. Shimao's pyramid-like structure is particularly striking. Unlike Egyptian pyramids, it was not a tomb. Unlike Mesoamerican pyramids, it does not appear to have been a stepped temple in the same sense. It functioned as a monumental platform supporting elite activity, administrative, ritual, or residential. From its summit, rulers could oversee the city and surrounding territory. The construction required enormous labour coordination. Stone blocks were quarried, transported, and assembled with precision. Walls extended for kilometres. This level of organisation implies centralised authority and resource management. Yet around 1800 BCE, Shimao declined. The reasons remain debated. Climate fluctuations may have reduced agricultural productivity. Political shifts may have redirected trade routes. Rising powers in the Central Plains may have absorbed or displaced northern polities. There is no clear evidence of catastrophic destruction. Instead, the site appears gradually abandoned. Over centuries, wind and lowest dust softened its contours. By the time later dynasties recorded their histories, Shimao was already forgotten. Today, as archaeologists continue to excavate its terraces and walls, Shimao reshapes understanding of early Chinese civilization. It suggests that state formation was not linear or singular. It emerged in multiple centres. It rose and fell in cycles. The skulls embedded in its walls speak of ritual intensity. The jade inlays speak of symbolic power. The pyramid platform speaks of hierarchy and governance. Standing at the base of the ruined terraces, with winds sweeping across the plateau and ravines cutting deep into the earth, one feels the scale of what once existed here. This was not a marginal outpost. It was a city commanding landscape and belief. Shimao was not erased by conspiracy or suppression. It was obscured by time, by shifting political centres, and by the absence of surviving written memory. Its rediscovery reminds us that history is not fixed. It expands with excavation. It adjusts with new evidence. In the quiet hills of Shanxi, where stone walls rise from eroded earth and distant horizons stretch wide beneath northern skies, Shimao stands again, not as a legend, but as a reminder that civilization's origins are often more complex, more distributed, and more layered than traditional narratives suggest. And in that rediscovery, the forgotten stone city resumes its place, not in myth, but in the evolving story of human beginnings. The desert fortifications of Al-Madain Saleh. In the northwestern deserts of Saudi Arabia, where sandstone cliffs rise from wide open plains, and the silence of the landscape feels almost architectural in its vastness, stands one of the most visually striking archaeological sites in the Arabian Peninsula. This is Hegra al-Hijr, more commonly known as Al-Madain Saleh, a UNESCO World Heritage Site celebrated primarily for its monumental Nabatean tomb facades carved into towering rock formations. Visitors often come for those tombs. They photograph the ornate entrances, the stepped crowns, the inscriptions carved into sandstone during the 1st century BCE and 1st century CE, when the Nabateans controlled trade routes stretching from Petra to southern Arabia. But beyond the iconic tomb facades, beyond the decorated cliffs, the desert holds quieter structures. Stone enclosures, low defensive walls, railway fortifications, features that receive far less attention. Scattered across the open plains surrounding the carved tombs are rectangular and circular stone-built compounds constructed from local sandstone blocks, laid without mortar, forming perimeter walls whose purpose is not immediately obvious. These structures do not carry elaborate inscriptions. They are not decorated, they are practical, and they belong to multiple historical layers that overlap at Al Madain Saleh. After the Nabatean period, Hegra became part of the Roman Empire in 106 CE, and later, centuries afterward, the region fell within the Ottoman sphere. In the early 20th century, the Ottoman Empire constructed the Hijaz Railway, a strategic rail line linking Damascus to Medina, designed to facilitate pilgrimage travel and strengthen imperial control over the Arabian Peninsula. The railway passed directly through Al Madain Saleh. Stations were built, water towers erected, fortified posts established to protect the line from tribal raids during periods of unrest. Some of the stone enclosures visible today are associated with this early 20th century railway infrastructure. They functioned as defensive compounds, perimeter walls around garrison positions, supply depots, and communication points. Built quickly but solidly, they blend into the desert landscape, their rectangular outlines still visible from aerial views. During World War I, the Hijaz Railway became a target during the Arab revolt against Ottoman rule, famously supported by British forces. Sabotage operations damaged sections of track, trains were derailed, fortified posts were attacked. The ruins of those defensive positions remain, quiet evidence of a modern conflict layered atop ancient ground. But not all stone enclosures at Al Madain Saleh are Ottoman. Archaeologists have identified earlier enclosures dating back to the Nabatean and possibly pre-Nabatean periods. Some appear to have functioned as animal corrals or caravan staging areas, enclosed spaces where livestock or goods could be secured overnight along trade routes. The Nabateans were master organisers of desert trade. They controlled the flow of frankincense, myrrh, spices, and other valuable commodities moving between southern Arabia and the Mediterranean world. Such trade required infrastructure beyond monumental tombs. It required wells, storage areas, security. The low stone enclosures scattered across the plains may represent this logistical network, functional architecture supporting economic power. Yet because they lack the dramatic verticality of the tomb facades, they are often overlooked. Tourist routes focus on carved monuments. The railway station, though visually striking with its Ottoman-era architecture, is treated as a later historical footnote. The desert fortifications, whether Nabatean or Ottoman, sit quietly beyond the main visitor pathways. When viewed from above, however, their layout becomes clearer. Rectangular compounds align, strategically near railway lines. Circular enclosures appear positioned along ancient caravan corridors. Some walls follow natural rock contours, using the landscape itself as a defensive advantage. The blending of periods at Al Madain Saleh is subtle. A Nabatean tomb carved in the 1st century BCE stands not far from an Ottoman fortification built in 1908. Between them lie centuries of silence and shifting political control. This layering creates the impression that the site's story ended with the Nabateans. But in reality, it continued, transformed, but persistent. The fortifications remind us that deserts are not empty spaces. They are corridors. They are contested. They are strategic. From ancient caravan traders to Ottoman railway engineers, each era adapted the terrain to its needs. Stone enclosures built for livestock may later have been repurposed for military defence. Railway stations may have reused earlier foundations. The landscape accumulates history. Today, as wind moves across the sandstone plains and the sun casts long shadows against ruined walls, the fortifications remain understated. No elaborate carvings announce their presence. No polished facades draw immediate attention, but they are essential pieces of the larger narrative. They show how Al Madain Saleh was not only a sacred necropolis, but also a working landscape, a node of commerce, transport, and defence. They reveal how infrastructure underpins monumentality, and they remind us that history does not occur in isolated chapters. It overlaps, it reuses, it adapts. Standing near the remains of a Hijaz railway station, its stone blocks weathered but intact, one can see both ancient tombs and modern fortifications in a single frame. The past here is not singular, it is layered, and in that layered quiet, between carved cliffs and railway ruins, the desert fortifications of Al-Madain Saleh continue to endure, not as mysteries but as overlooked witnesses to the many eras that passed across this vast Arabian plain. Filitosa, the stone warriors of Corsica. On the island of Corsica, where rugged mountains descend toward Mediterranean shores and olive groves, stretch across sunlit hills, there is a prehistoric site that feels both European and older than Europe itself. This is Filitosa, a megalithic complex whose carved standing stones, known as statue menhirs, date back more than 4,000 years, long before Rome, long before Greece shaped the classical world, before written records defined Western history. Filitosa was already here. The site lies in southern Corsica, overlooking a fertile valley. It was rediscovered in 1946 by a local landowner who noticed unusual upright stones emerging from the landscape. What began as curiosity soon became excavation, and excavation became revelation. Archaeologists uncovered circular stone towers, walls, and, most strikingly, anthropomorphic statues carved directly into granite. These are not simple standing stones. They have faces, weapons, armour. The statue menhirs of Filitosa are tall, elongated figures carved from local stone. Some reach over 2 meters in height. Their surfaces bear incised features, eyes shaped like almonds, straight noses, subtle mouths. Across their torsos are carved representations of daggers and swords. Some show belts, some appear to wear helmets or stylized headgear. They are often referred to as warrior stones. Radiocarbon dating and stylistic analysis place the earliest occupation of Filitosa around 3300 BCE during the late Neolithic period. The statue menhirs themselves likely date to the late 3rd millennium BCE, overlapping with the early Bronze Age. At that time, Corsica was not isolated. It lay along maritime routes connecting mainland Europe, Sardinia, and the broader Mediterranean world. Yet the people who carved these stones left no written language behind. We know them only through material culture, pottery fragments, stone tools, burial structures. And these warriors, the presence of carved weapons suggests a society familiar with organised conflict. The Bronze Age saw increasing competition for resources, territory, and trade access across the Mediterranean. The statue menhirs may represent ancestral figures, leaders, protectors, or symbolic embodiments of strength. Some researchers propose that they functioned as territorial markers. Others suggest they were part of ritual landscapes tied to burial practices or community identity. At Filitosa, the statues were found integrated into circular stone structures known as tori, defensive towers built during later occupation phases. In some cases, earlier statues appear to have been deliberately broken and reused within tower walls. This suggests cultural transition, a shift in power, perhaps even internal conflict. The tori resemble, in smaller scale, the Nuraghe towers of neighbouring Sardinia, hinting at shared or parallel architectural traditions across the Western Mediterranean. The builders of Filitosa remain unnamed in history. They predate Celtic migrations into Corsica. They predate Roman occupation. They belong to a prehistoric cultural horizon whose boundaries are still being defined. What makes Filitosa especially compelling is its combination of artistry and austerity. The carvings are simple, yet intentional. There is no attempt at naturalistic detail beyond essential features. The warriors stand upright, elongated, abstract. They do not smile. They do not gesture. They endure. Granite is not easy to carve. It requires patience and repetitive hammering with harder stone tools. The decision to carve human forms into megalithic slabs represents significant investment of time and labour. This suggests that the statues carried deep symbolic importance. Standing among them today, under Corsican sunlight, surrounded by low stone walls and distant mountain silhouettes, one senses continuity between land and sculpture. The stones do not dominate the landscape, they belong to it. Their surfaces have weathered under millennia of Mediterranean climate, wind, rain, heat, yet the carved daggers remain visible. The faces still emerge from granite. Filitosa challenges simplistic narratives of European prehistory. Before classical civilizations formalized art, governance, and warfare in written accounts, communities across the continent were already constructing monumental architecture and encoding social meaning into stone. These warriors may represent elite status, perhaps even the earliest visual representations of armoured figures in Western Europe. They speak of hierarchy, of organised defence, of identity tied to weaponry, and yet they also speak of memory. The fact that later inhabitants reused and repositioned some of the statues suggests evolving interpretation. Were they venerated ancestors, defeated enemies, symbols recontextualized by new generations? We cannot know with certainty. No inscriptions guide us. No myths survive in textual form. What remains is the material record. Stone towers layered atop earlier monuments, statue menhirs incorporated into defensive walls, pottery fragments hinting at domestic life. Filitosa was not a single-phase settlement. It evolved over centuries, reflecting shifting social structures and external influences. By the time classical Mediterranean civilizations rose to prominence, the culture that built Filitosa had already transformed or dissolved into later populations. Its memory faded, its stones remained. Today, the site is quiet. Visitors walk between the statues, reading plaques, photographing profiles carved 5,000 years ago. But beyond tourism, Filitosa remains a key to understanding prehistoric Europe as a mosaic of regional societies, interconnected yet distinct. The warrior stones stand not as evidence of lost super civilizations or forgotten empires, but as markers of a complex Bronze Age society negotiating identity, territory and power. Under open Corsican sky, surrounded by olive trees and granite outcrops, the statue menhirs endure as silent figures from a time before history began to write itself. They do not tell their names. They do not narrate their victories. They simply stand, carved, weathered, and rooted in the landscape that shaped them. And in that stillness, the ancient builders of Filitosa remain present, not erased, not mythical, but etched in stone long before classical Europe ever took form.